I'm very happy to open our online symposium. Demographic consequences of COVID-19. And of course, there is no need to talk much about the consequences of pandemics that change the life at most parts of our planet. Significant behavioral changes and some changes, behavioral norms probably will be still with us after pandemics is over. So it's really a very, very devastating and important event. Since COVID-19 had so devastating effect in many parts of the world, it's not a surprise that so much research is now being conducted in this field. Of course, the top priority today is to protect the health and well-being of people. And it is clear that most of the resources are aimed today to fulfill this task. But research related to the consequences of COVID-19, to health system, to economics, to political system is emerging very fast. And there is also a very special niche that may be the best studied by demographers. As demographers, we can look into some initial estimates, for example, of the years of life lost due to COVID-19. We can analyze what would be the impact of COVID on population size, on population distribution of people. What might be the effects of COVID and lockdown also on fertility expectations? What virus, how virus hits differently men and women? How demographers can contribute to successful policies aimed at diminishing negative effects of COVID-19. So all this type of questions are relevant to what demographers can do. So the aim of this symposium is to share the results of some recent research in this field, and we will discuss also issues mentioned above, and we will discuss also the challenges that demographers may face in studying demographic consequences of COVID-19. Our symposium also serves as a platform to discuss and identify the research directions where demographic approaches can provide scientific and policy contribution. Definitely that much more data will appear at some later stages. But even today, there are many issues related to demographic consequences of COVID that we can address with some confidence. The symposium is organized jointly by International Institute of Applied Systems Analysis, IIASA, and the Russian Presidential Academy of National Economy and Public Administration, RANEP. The collaboration between IIASA and RANEP has a long tradition that most recently resulted in a series of important joint projects, such as Russian population projections by regions, different data sheets, different brochures where we really analyze and study Russian population. We hope that our meeting will run smoothly, although online conferences are still new to many of us. Now, today we have both leaders of two organizing organizations present here, and they will welcome our participants of this meeting. So it's my pleasure to give the floor to Professor Vladimir Mao, Director of Russian Presidential Academy of National Economy and Public Administration, who will give his welcoming address to participants of our meeting. Professor Mao, the floor is yours.
Thank you very much, dear colleagues. First of all, I wanted to thank Professor Sergei Sherbov and Professor Albert van Jaarsveld for that they agreed to launch at this conference. For us, for our academy, this is one of the most important topics for analysis for the months or even years to come. Demography, as well, to my mind, demography as well as IT and economic issues have become one of the pivotal questions for future discussions and analysis. To my mind, you know, about in 2008 or 2009, one of the leading economists and once said that crisis is a bad time for people, but very good time for economies, because they have a lot of area for analysis and discussion, and demand for economies has been growing. I would say that current crisis is very bad time, but it's very good time for much a broader scope of professions, not only for economists, for demographers as well. And I do believe that this current symposium will contribute a lot to understanding of what has been happening in this country and globally regarding the prospects of population. Each deep structural crisis creates new research agenda. It was the crisis of 1930s, the Great Depression created new agenda. The 1970s substantially reshaped challenges which economists faced with. To my mind, the current pandemic crisis interlinked with economic crisis will result, will have as one of the important results a new research agenda. As economists, I see some important points, including, say, new macroeconomics, substantially new approach to inequality or equality issues. And to my mind, of course, demography is quite old analysis, and I think that demographers could not be puzzled by anything. Economists could be puzzled, but not demographers. But I think this crisis has already raised and will raise some deep, important questions for further analysis. I wish all the best to participants of this conference. I wanted to thank again Sergei Sherbov for formation our meeting, and I wish us very good discussions and interesting results. Thank you very much. On behalf of this academy, I wanted to invite everybody to have a series of such debates. I think, say, several months or a year from now, it will be very interesting to bring us together to reflect the results of this conference, of this event, and the events of the forthcoming year. Thank you very much again.
Thank you very much. Thank you very much, Vladimir. It's also my pleasure to give a floor to Professor Albert van Jaarsveld, who is the Director General and CEO of International Institute for Applied Systems Analysis. So, Albert, please, the floor is yours. Just unmute. No, you have to unmute. Albert, unmute, please.
Thank you.
Yeah.
Sorry, thank you. Thank you very much, Professor Sherbov and Professor Mao, for this opportunity for us to participate in this joint venture on a very important topic of demography, as you indicated. We have been reflecting about COVID-19 and what it means for humanity moving forward, and just an interesting observation that another flu that resulted in some 500,000 deaths a century ago. There were 3 mitigation responses put in place by society to deal with that flu. The one was to stay at home. The second one was to wash your hands. And the third one was to avoid large crowds. So it's interesting that 100 years later, when faced with an unknown crisis and an unknown enemy, our response is exactly the same. But I hope when we think about the demographic consequences of COVID-19 moving forward, we do all understand, I think, and you will understand better than I do, that there are going to be significant consequences for the kind of economies that we pursue, what is possible and what's not possible in different parts of the world. The economies are going to be changed in some fundamental sense. What is the nature of the tax base going to be moving forward? What is the workforce size and shape that we have to deal with? What are the limits in terms of dealing with aging populations across the world that we have to tackle as a community moving forward. I think all these things are going to unfold over the coming years. I think this COVID crisis that we are dealing with at the moment, which is, as you said, is essentially a health issue at the moment, is going to develop into a very long-term economic legacy that we have to tackle and deal with across the world. So this conversation for me is very important, and I assume that this will be the start of that conversation and not the end of it. But I wish all of you well in your deliberations to explore the possibilities and the limits and constraints that may affect us moving forward as far as demographic realities are concerned across the world. I'm hoping that in the process we can also unleash and get to understand some demographic possibilities and opportunities that will actually have a positive consequence for the economy, but also for many societies around the world. So I wish you well in your deliberations and look forward to see the outcome of your conversation in the near future. So thank you very much for joining us, and I wish you strength in your conversation. Thank you, Sergey.
Thank you so much, Albert. Okay, so we can probably now move to the part one of our meeting. Actually, there will be more and more people coming because we have some people from the United States, from South America. So of course it's very early there, but they will also show up a little bit, probably a little bit later. Our meeting is also recorded, and eventually, as I understand, it will be also on YouTube. So people know that, and so some people who won't be able to attend it today, they could follow our meeting on YouTube later. So we have first part. We have 4 presentations during the first part of our meeting. Each presentation will last 15 minutes. Then we have 5 minutes for questions and answers. And at this moment, at the part 1 and part 2, we only allow questions and answers, no discussions, because for discussions we have the final part, which will last almost 1 hour. So our first presenter is Simone Ghislandi from University of Bocconi and also IIASA, and his talk is Human Cost of the COVID-19 Pandemic, Excess Mortality and Years of Life Lost in Italian Epicenters. Simone, floor is yours.
Thank you, Sergey. Thank you, Professor Mao, and thank you to IIASA and RANХiGSA for inviting me. I'm going to share the screen. Let me know if you can see. Can you see?
Yes.
Yes, we can see, yes.
Okay. No, it's better to do this. Now, I prefer to, okay, I stay on this. The reason why we've been invited is because we have a paper since May, basically, updated constantly. Now it's in its final version on the human cost and mortality in the major epidemic center in Italy. Yeah, I will skip the part where, since I have only 15 minutes, I will skip the part where I explain what COVID is and all that, because I guess you all know by now. But Italy was really the first country outside Asia to be hit hard by an epidemic wave. Now it's an experience that many other countries can share with us. But we were the first in line and the first to begin and the first to end the epidemic wave. So we probably have something to say in terms of data as well, and demographic data as well. Nevertheless, the COVID-19 is not over in Italy either. And so looking at an assessment of the demographic consequence of COVID-19 while the epidemic is still ongoing might be a little bit, might look a little bit too early to do that. The reason why we do that is, in fact, because, well, first of all, we are interested in the human cost, life lost, because this is going to be a crisis that is going to last, as Professor Mao and Sherboff said, pointed out. But it is, we should never forget that this is a crisis that, differently from the previous epidemic crisis, is a health crisis that turned into an economic crisis. I'm an economist as a background, and I became interested in demography when I working with Professor Sherboff on when I understood the role of how the changes in mortality can actually tell us a lot about the human development and the human side of a society, which is important also for the economy. So ignoring this dimension would be like ignoring the elephant in the room, really, in this case. And also because assessing the first wave of human cost would be crucial, and I will talk about. I will mention this at the end of the presentation for informing the health economic policies, because knowing the size of the problem is also important in order to understand the type of policies that we have to settle in order to tackle it. So what we do here is to measure the human cost in terms of loss of life expectancy, so loss of life years, basically. And we rely on Italy, and we rely on the fact that in Italy, the pandemic wave started in more or less at the beginning of March, actually the 21st of February officially, and ended, as we can show in the data, more or less around the 30th of April, at the end of April. So what we are doing here in order to calculate, to understand the human cost in terms of loss of life expectancy is our paper is basically based on two main pillars that are important for the work. The first one is related to the fact that we, since May, but also before that, and now this position is shared among the scientific community quite a lot. We don't trust that much the official numbers on COVID-19 deaths. Official number of COVID-19 deaths tend to underestimate the mortality of COVID-19. And there are practical reasons for that, simply because in most countries, like Italy, for example, someone is classified as a COVID-19 death if they die after being tested. But many people die at home, many people die in nursing homes where during the waves, typically countries or governments don't have the possibility to test everyone. So there is, and post-mortem tests are rare. Also, another reason why might be underestimation in the official figures is that different countries measure and classify COVID-19 deaths, related deaths in different ways. So there was at the beginning of the pandemic this debate on do you die for COVID for or with the virus. This debate is kind of over, but the heterogeneity in the measurement still remains. So we focus on all-cause mortality. We don't go into the details of why someone died. We just focus on mortality altogether. And the other pillar is the geography. This has not been stressed enough, I think, in the literature, because if you look at the Italy altogether, for example, the virus, the epidemic didn't hit the country in the same way. It hit the country in very geographical, limited areas. If we consider, for example, life expectancy lost in the whole country, we are again underestimating because we are diluting the effect. Okay, but the real experience of the epidemic must be valued by defining the right area where the pandemic has affected the outcomes most. We use ISTA data. We were lucky enough to have this daily number of deaths by municipalities from 2015 until 30th of April of 2020. We merged this data with population at birth. The ISTAT is the Office of National Statistics of Italy. They work very well, and this data has been around for a while, continuously updated, and this is really the final version because we have data for more than 95% of the municipalities in the whole country. Focusing on the results, I will mention two types of results. One is the excess mortality, and the other one is actually the matrix of human cost, which is the life expectancy, loss in life expectancy as we measure it. This is the map of Italy, and the darker red areas are the ones that witnessed excess of all-cause mortality in the country. So you see that this area, the area in bold, is basically Lombardy with the additional province of Piacenza. And when we look at Lombardy more in detail, you see that, and these are the municipalities, you see that there are areas that are much much harder hit than others. And these areas are the one in the center, very red, is Bergamo, which is also the province I come from. So it was also a personal assessment, a personal reason why I decided to write this paper, really. And we analyze 5 provinces, the mostly hit 5 provinces, which are Bergamo, Brescia, Lodi, Cremona, and Piacenza, which are all around, which are the red parts here in the map. I don't know if you can see, but I'm actually pointing at them anyway. In any case, you can see from the map. Here I'm presenting results only quickly for Bergamo only, which is the most representative province. Here you see the epidemic wave in red is the mortality, daily mortality by age. In 2020, in blue is the average daily mortality for 2015-2019. And you can see that the epidemic wave was very hard. Very strong, especially for the 70+. It started at the beginning of March and it ended more or less in the end of April. The third vertical line that you see is the lockdowns that we imposed, which was on the 8th of March, but it was clearly too late because the epidemic wave was already ongoing. So as a result, we were basically hardest hit province, and the epidemic wave lasted 8 weeks more or less, with a certain number of deaths, which with a mortality rate that here is the population. The overall population, for example, for Bergamo is around 1 million of the province. And here you see the increase in mortality rate from compared to the previous year, and the increase was for certain age class, age category was up to 340%. So age was clearly a risk factor, a very strong risk factor. But the increase in mortality rate was the strongest one was registered in the category 70-79 in terms of age. Also, sex gender was an important factor, with the males being up to 3.7 times more likely to die, higher mortality rates than females. Nevertheless, I point out that women died a lot in Bergamo as well, but this is due essentially to the fact that the women are overrepresented among the elderly, and in Bergamo the life expectancy is pretty high, and the number of elderly women especially is particularly high. Now, then we have to synthesize this mortality rates and this excess mortality evidence in life expectancy, and we provide 2 measures. One is the quadrimester life expectancy, so that is using the mortality rates from the 1st of January to the 30th of April versus the same period in previous years. This is entirely based on data, no assumptions, hard data only, because we have them. we can see and we can have a measure of the first 4 months of a loss of life expectancy compared to the previous year. When we move to the annual life expectancy, we need to do some assumption regarding what is going to happen after the 30th of April. And here the typical assumption is harvesting or full harvesting. The assumption of full harvesting is very unrealistic. In fact, it means that everyone that died during the COVID-19 would have died anyway during the year. And it's an upper bound, if you want. The more realistic assumption is the business as usual assumption of no harvesting, meaning that the mortality after the epidemic wave goes back to normal as it was in the previous years. We make no estimation or assumption about a second wave coming because this is not the point of the paper. The results are very striking and very, I mean, it shocked us in a way because it was a very strong loss in life expectancy when we look at the quadrimester life expectancy. I can show the graphs later, but I don't have time really. We are talking about 8 years for males and 5.8 years for females in Bergamo, and 6 years in the lowest, in the least affected provinces for males, and 3.6 years which is Piacenza for females. So this is to be, when we move at annual level, we have more or less half of the figures. From 8 years, we move to 4.1 years, from 5.8 years to 2.6 years for men and women, respectively, in Bergamo. Other provinces are less hit, but still we have in the business as usual scenario, as we saw before. Now, the results that we have are somehow expected, but stronger than we expected in a way, at least for Bergamo, because the mortality is typically associated to elderlies, and so this should affect the loss of life expectancy much less than one would if we compare, for example, to the Spanish flu of the first that was mentioned before. Nevertheless, the number of deaths was so high that the life expectancy actually was reduced significantly. In the discussion, to conclude, because I have only 1 minute left, our conclusion is that the demographic variables are crucial in this type of epidemic. It doesn't need to be like that in every epidemic, but in this specific epidemic, age is a very strong risk factor for mortality. The discussion that follows about comorbidities are somehow redundant because there are other papers coming out. Basically, most of the people that die after 70, 79 have comorbidities, but so have people that don't die in this sense. So essentially, age remains a crucial risk factor for mortality. Sex is also important, but as I said, especially in countries like Italy, where life expectancy is high and women are overrepresented among the elderlies, the virus is risky also for women in this sense. The final result, if you want to compare, to have an idea of how big was the loss of life expectancy, is that for these provinces, and only for these provinces, this was by far the hardest, the lowest, the deepest drop in life expectancy since the Second World War. Is not comparable to the Spanish flu and the First World War because of other reasons, of course, but it was a big hit especially for the geographic areas that we are considering. And if we have to take this because I live in Italy and I live in Lombardy, there is a lot of discussion about another wave and the possibility to introduce a lockdown. And another wave like this in Lombardy would basically make it the annual loss in life expectancy look more like the quadrimester loss in life expectancy. And it would simply be not affordable in terms of human cost. It would make the life loss worse than the one we have registered in the Second World War, by the way. So we are expecting that our governments are, and we are all trying to avoid this possibility, and that's why much discussion about other lockdowns can be raised at any moment from September on in Italy, at least. I think I passed 2 minutes over my time, so I don't know if it's okay.
You can close the screen sharing.
You can close the screen share.
You.
Yes, stop share. Yeah.
Okay. Thank you so much, Simone. Now, questions and answers. So those of you who want to pose a question should just write the questions in this Q&A sort of button at the bottom of your screen. So are there any questions? People whom we see here, they can probably just ask a question also. Are they just raising the hand? No. Okay, since we don't see at this moment any questions, maybe some questions come during the discussion. So what I also would suggest that I follow the time, so I always send a private message to the speaker about how much time is still left. So it may be some sort of indication. Okay, if there are no questions, I don't see any questions in Q&A in our question room. So then we move to the second presentation. And our second presentation is, the speaker is Guillaume Roy, and he talks about assessing the potential impact of COVID-19 on life expectancy. Guillaume, the floor is yours.
Yes, thank you. Wait, let me share my screen.
And if it's possible, could you also make the big sort of PowerPoint, not just
I will.
The big presentation size.
Wait, like, is it big? Wait.
No, you can just press a regular, you know, this, well, I think you just press a regular presentation button in PowerPoint.
Do you see the full screen
now?
now?
It's now perfect, yes.
Perfect. Okay, so I will present some estimates I did with my colleague Raya Mutarak and you, Sergey, on the potential impact of COVID-19 on life expectancy. So we know that in severely affected country, an epidemic can result in a big impact on the period life expectancy. This is, for instance, what happened in the US for the 1980 influenza outbreak. We saw there's a very clear break in the historical trends in life expectancy. The loss was about almost 12 years in life expectancy, but this is a period breaks. And shortly after, it recovers. So yeah. So this is what I try to assess here. What will be this break in the historical trends in life expectancy with the actual pandemic of COVID-19? Yeah. So we've tried to provide a first estimate of the potential impact of the virus on period life expectancy. We know already some bias adjusted age-specific case fatality rate. And with those rates, we build different scenario of prevalence of infection in the populations. We apply the calculation to different life tables. So either North America and Europe, which where life expectancy is very high, Latin America and the Caribbean with medium high life expectancies, Southeastern Asia with medium life expectancies, and Sub-Saharan Africa with low life expectancy. So it needs to be clear that this is not a prediction of what will happen to life expectancy in this country, and it's not also an assessment of what happens in the past. So just to see how the actual age-specific case fatality rates that we know from the disease might affect the life expectancy according to different scenarios of prevalence. So to assess this impact, we use micro simulations. So we build with SAS a discrete time micro simulation model that simulates the life of individual week by week for a period of 1 year. So we have four main parameters in the model. First, we have the probability of dying. So this is the QX from a normal life table that we picked from the World Population Prospect of the United Nations. We have the prevalence rates of COVID-19. So this is what we set in assumptions. For the prevalence rates, we have no age differential. We assume same rate for our age group. And we assume a distribution following a normal distribution centered in the middle of the years. The third parameter is the length of illness. So we set it at 2 weeks because this is what on average the disease will last for 2 weeks. And finally, the age-specific probability of dying of the disease, which can only happen during the 2 weeks of illness. Yeah, so the model is this discrete time. We have 52 weeks, so 52 steps and 3 events. So the way it works, we start with the week 1. We simulate if the persons die from any other causes of disease, QX. If the person doesn't die, then we simulate the probability of being infected by COVID-19. If the person is infected, then we simulate the probability of dying of the disease. And if the person survives, or if he's not infected, go to the next week, week 2, doing the same events until the end of the simulation after 52 weeks. So we did 100,000 simulations for each age group and each regions to have consistent result. Now the crucial question is, what are the fatality rates from COVID-19? So we know that in the official accounts, there are many sources of bias. As Simone talked a little bit, we know that there's underreporting of milder case. So since the more severe cases are more likely to die and more likely to be reported, then this will create an upward bias in the fatality rates. There's also a time lag between the diagnostic and the death recovery. So if we just look at cross-sectional prevalence and number of deaths, we know that some people that are actually infected will eventually die. So they are counted in the denominator, but not in the numerator. And this will create the opposite, a downward bias in the fatality rates. And finally, there's also the methods of counting the deaths or the disease varies from country to country. So this is something I just picked on the internet to show the different fatality rates by country. There's a big discrepancies according to the different country, even with a similar age structure. So in the Belarus, it's about 0.5% as compared to France, almost 20%, USA in the middle at about 5%. So this is why I didn't use the official count. I use instead studies that try to estimate the bias-adjusted age-specific case fatality rates. So this comes from a study of Verity et al. Published recently in the Lancet and Infectious Disease. They use a Bayesian framework, use different sources to correct for the different bias and see what would be the real case fatality rate from the disease. However, they use data for China. So in my model, I need to assume that the age-specific fatality rate will follow the same trends as in China. So this is what it looked like. So this is a central estimate. So before the age of 60, it's below 1%. After the age of 60, it's gradually increased up to about 7–8% for the age 80 and over. And since it's this comes from Bayesian estimates, we have credible interval for this estimates. So with the 95% credible interval, it varies at the age of 80. It will vary from about 4% to almost 14%. If we compare with other estimates that have arrived later, so this is what has been in green. This is what has been estimated by the Institut Pasteur in France. So here it follows the lower estimates of Verity et al. Until the age of 17, but for the age of 80 and over, we are about in the same. The Korean, this is the reported data for Korea. So it follows about the same as our central estimates, because in Korea they did some testing. It was not specific only to the old person, it was also for the young. So we have maybe more accurate fatality rates in Korea compared to Italy, where the testing is more among the severely ill patients. So we have very high fatality rates for the older group. So basically our central estimate is about 3 times less than what observed in Italy. And this is why I didn't use age-specific prevalence rates. So basically there's no clear pattern in the age-specific prevalence rates of COVID-19. Depends on the way people are tested. So in Korea, as I said, it's about the same in all age group, while in Italy and Spain, it's much higher among the elderly because there are more tests on the elderly. So we test 6 scenarios like this. So the first scenario is 1% of the population is infected. So this will be a scenario where the spread of the disease is well controlled. Then we gradually increase until 70%. So this will be the scenario where there's no control at all and the disease is spread in almost all the populations. So result, this is how it looked like. This is for North America and Europe first. So approximately each percent increase in the prevalence of the COVID-19 reduced life expectancy by about 0.1 year. So this means that at 10% of prevalence rate, we lose about 1 year in life expectancy. At 50%, we lose about 5 years of life expectancy, and at 70%, almost 7 years are lost. This is for the central estimates, and the life expectancy will for 2020 will just pass from 79 years old, about at 0%, so with no pandemics, down to 73% at 70% of prevalence rates. And when we look for the credible interval of the age-specific fatality rates, it could be, so the loss at 70% will be between 4 and 11 years in the year loss in life expectancies. With the model, I also calculated the total fatality rates. So I used the age-specific fatality rates, applying to the age composition of the population to see what will be the fatality rates in the population having the age structure of North America and Europe. And with those estimates, it will be 1%, about twice less for the lower estimates and twice more for the upper estimates. And now, so this is, I just try to put on a graph what it will look like, the break in the historical trend. I just use Swedish data. So this is in blue, this is the observed and projected life expectancy in the absence of pandemic. So in gray, this is at 70% the central estimates. So we go back basically at the level of the 80s, 70s. And with the higher fatality rates, we go back almost in the life expectancy in as what observed in the 50s. Now for Latin America and the Caribbean, the impact is a bit less than in North America because life expectancy is also lower, so there are less survival at older age. So at the end, at 70% of prevalence rates, we lose about 6 years instead of 7 in life expectancy. But what is interesting is that the total fatality rate in this region will be about twice less because of the younger age structure of the population. So even if the impact on the life expectancy is similar to North America, the total number of deaths will be about twice less because of younger age structures. For Southeastern Asia, where life expectancy, again, is much lower than in Europe, so 73 years instead of 79 for Europe and North America. So at the end, the less there are survivals at older age, in the life table, the lower is the impact of COVID-19 on life expectancy because it will affect people that are less likely to die. So here, the first years of life expectancy that is lost correspond to a prevalence rate of about 15% instead of 10% for North America and Europe. And at 70%, we lose about 5 years instead of 7. And for Sub-Saharan Africa, where the life expectancy is very low, so the impact of COVID-19 will be much smaller. So the first years of loss in life expectancy is reached at about 25% of prevalence rates instead of 10%. And at 70% of prevalence rates, we lose 3 years in the life expectancy. And here, if we look at the total fatality rates, so we assume the exact same age-specific fatality rates than in North America, but we will have a total fatality rates about 5 times lower because again of the much younger age structure in those regions. So in summary, as long as the prevalence of COVID-19 remains low in a region, it will not affect that much the life expectancy. But when we exceed a certain threshold, we will start seeing a clear break in the secular trends. So life expectancy usually increase every year by about 0.2 years in the high life expectancy regions, which means that at about 2% of prevalence rates, this secular trend is suspended. And the more the prevalence is higher, the bigger will be the break in the historical trends. At 10%, we lose basically 1 year. And at 70%, it's about between 4 and 11 years in high life expectancy regions and lower in lower life expectancy regions. But we will see then a very clear break in the historical trends. So we did the modeling for broad regions, but we can also apply the result for smaller regions, which means that if a specific village or cities or regions reach the 70% of prevalence, then even if at the national level we don't see this impact, it can be observed at a smaller level, a smaller geographical level. And well, finally, to conclude, some limitations. Well, this is some, of course, very gross modeling. So the results will be interpreted in the context that all other things are kept constant, and which is a bit unrealistic. So we assume that the age-specific fatality rates will be the same in our country as what observed in China, which is unlikely to happen because each country has its own health infrastructures, and likely they will have different age-specific fatality rates according to their health infrastructures. And also, we didn't link mortality rates to prevalence of COVID-19. While we can assume that the higher is the prevalence of the virus, the more the infrastructure will be overloaded, and the higher will be the fatality rate from both COVID-19 and from other causes of disease. So this is something that is missing in the modeling, but we can still have a kind of broad idea of how the epidemic will impact life expectancy. Thank you.
Thank you very much, Guillaume. Now, if you now unshare your screen, yes, thank you so much. Any questions? Again, look, questions and answers. So again,
I have one question, if I may, Sergey.
Okay.
So I was puzzled by you saying that if you have younger age structure of the population, you have fewer years lost to the epidemics. Could you explain or provide some intuition to this? If I was correct.
No. I said
in my understanding.
I said when there are less survival in the life, less survival at older age in the life table, the impact is less on the.
Yep.
But so what I said about the younger age structure is about the total fatality rate.
Oh yeah, sure.
So
Thank you.
so when I apply the population structure on the calculation, I calculate the total. Yeah, okay, you understand.
There was someone, Stephanie, do you see there was someone wants to pose a question? Pavel Trunin. Well, actually, please use, we will have the questions asked later. I mean, we'll have discussions later when we could all speak, but otherwise at this moment, it's better if you just pose a question through Q&A. But okay, Pavel Trunin, you can just ask your question because you are, I think.
Yeah, I can pose my question later if you want.
No, that's fine, that's fine.
Okay, so I'm not a big expert in demographics, so maybe my question is a bit naive, but still, you said that this COVID-19 will cause a drop in life expectancy, but my question is how persistent this drop is. I mean, will we see this drop in life expectancy just this year, and after that it may, you know, return to the previous trend, maybe in 1 year or 2 years, but the trend will, different countries will reach the previous trend? Or do you mean that we will see a permanent downward shift in the previous trend, and each year from now on we will see lower life expectancy than before COVID-19? Thank you.
It will be a break, probably 1 year, 2 years, until until either there's a herd immunity or either there's a vaccination, but it will not be something that will last forever. This will be very a periodic break in
So
life.
you mean that it will be temporary
Yes,
drop
yes,
in
yes.
life expectancy?
Very likely it will be, we don't really know the future. Maybe the virus will mutate and create something else, but for now, it will be very unlikely that it will be something that lasts for more than 1 year, 2 years.
Mm-hmm.
I can also just add a little bit. So there could be so-called, how demographers call harvesting effect. So it can also happen that people, the weakest people are dying now, are more affected by the COVID. So which means in principle that if there's no new wave of COVID or some modification of COVID, then in principle life expectancy can even slightly increase next years.
Thank you.
Any more questions?
So Gay, if I can jump in quickly in the harvesting effect, I guess as Simone has shown in the previous presentation, so in the hardest hit area, it's probably unlikely that harvesting effect would happen, because in certain area we already exceed the quota of death throughout the year compared to the previous year. So just to point out that, yeah.
Thank you. Any more questions? No, I see questions and answers are empty. Okay, then we move to the next presentation. Next presenter speaker is Sergey Shulgin, and he talks about potential impact of COVID-19 on population dynamics in Russian regions. Sergey, the floor is yours.
Thank you, Sergey. I'm struggling with sharing my PowerPoint presentation. Let me just check it again.
We are still all learning.
Do you see it right now? As I only see my own video feed.
Yes, we see it perfectly.
Perfect, thank you. I'm here to present our Russian population projections that we made with Sergey Sherbov, trying to assess possible impact of different COVID-19 scenarios. Actually, it's our early population projections. I see from the date of the final result, it was constructed by the April 2nd. So basically all our assumptions were formulated at the end of March, and all model estimations made at the beginning of April, end of March. We did not have enough data. I believe we still don't have enough data to perfectly estimate impact on mortality, fertility, or even migration, but we already saw the forthcoming trend. And the one observation that we could saw that abruptly stopped all the migration, both interregional and cross-country. Also, we see the major distribution of resources within healthcare to fight COVID-19. So we formulated a few scenarios trying to encompass that ideas. Actually, we formulated broad range. The first one is a really short-term effect of COVID-19, with the idea that we have only just small short-term stop of migration, some inertial tendency within life expectancy and fertility. We modeled stopped migration with the half of the migration from the previous year, both interregional and both external. And more severe scenario we model prolonging this effect. And basically the idea was that as within Russia we have a really strong long-term trend to increase life expectancy, the longer we wait till the next increase in life expectancy means the more severe impact of this COVID-19 we model. Basically, this was addressed a little bit in our previous discussion about the length of the term. Either it's 1 year, 2 years. Our worst scenario was that full recovery will take only the beginning of year 2024. And the short-term scenario was that next year we have already full perfect recovery with only short-term impacted only this year. And other three scenario, we called it COVID style 1, COVID style 2, and COVID style 3, when the index show how many years it will take for the full recovery. And for the last 3 most severe scenario, basically their fertility in some way and mostly mortality never basically return on the trend. It's still lagged behind those long increasing and really fast increasing life expectancy in Russia. So basically we're speaking that somehow mostly not only just due to epidemiological problem, but also through the distribution of resources, as actually Russia really tries to close the gap between between other countries with our really extremely low really low life expectancy. We're trying to close the gap with increasing rates of life expectancy. So while redistributing resources in healthcare, we somehow lagged. We fall behind this process. So our worst scenario that we come again to our trend only in a few years. And the middle term and short term scenario, it's something like that already next year will be on our long-term trend, or in next year will be in our long-term increasing trend in life expectancy. With all that in mind, we just run our major multi-regional demographic model. Basically, it's the same model we used, or variant of the same model we used to construct our demographic data sheets. This is collaboration between IIASA, RANEP, and Росстат that we present usually in biennial basis. So we formulated this simple, but as we see it, reasonable scenarios to model the different impact, different severity of impact of COVID-19. And we run it on multi-regional level. So basically we construct 85 regions, and for each regions we also simulate differently male, female, and also urban and rural. So basically 340 different cohorts. And now here I am presenting you aggregation of all this simulation with different scenarios relative to so-called baseline scenario. What is the baseline scenario? It's our update of our main multi-regional model with latest data from Росстат, in which we model the case when there would be no COVID-19 epidemic, pandemic. So basically we're comparing what would happen if there was business unusual, and for Russia it was really optimistic about life expectancy, not that optimistic as we have in trends in Росстат projection, but also quite optimistic. We have a long-term trend in life expectancy, somehow optimistic in with just slightly positive trend in fertility, mostly due to the strong frontalistic policy in Russia. And even if we see some temporary slowdown in fertility right now, probably we should expect in 10 years interval just slightly increase in total fertility rates. So basically this is our baseline scenario, is quite optimistic, not extremely optimistic, and we try to model these different COVID-19 demographic scenario by the severity of the impact. So here now I'm presenting the difference between those 4 scenarios and our baseline scenario. So what is the short-term scenario? It's that the topmost dot line. Actually, the length of the dot, it's the severity of effect, something like that. This is only some losses due to the lack in migration short term. And if you could see the difference the impact of all other more severe scenario is more prominent. And it basically consists of the two effects. The first one, the effect of both three pillars of demographic projections, mortality, fertility, and migration. And the first interval of all these trends, it's just combined effect. The more severe scenario, they have a longer, this prolonged effect. When we have shorter migration, we have a slow migration, we have a stall in fertility, stall, and even more severe stall in mortality, which is important for Russia. We have even more prominent effect this for male, as we have one of the largest in the world gender gap between male and female in mortality, and we have long-term trend closing this gap. Right now, this gap is 10 years. People in Russia lives, for women in Russia lives 10 years longer, expected to live at the best 10 years longer than male. And as we have a stall in this trend, that means the more severe effect also somehow through this effect, not closing the gap, impact more male actually. And we see that after the first more steeper interval of this graph, of this trend, we also see the prolonged effect, the cumulative effect of lagging. For the most three severe scenario, we have a lagging from our baseline mortality trends. That means that we are on the trends, but we still have a cumulative impact of a lower mortality in the years to come. And actually, it's also quite substantial, not only through the migration. Of course, okay. Also, we made some calculations for working age population, and idea basically the same, with only with exception that here we have no impact of fertility, and even stronger impact of migration, as most of migration occur exactly at this age interval. Also, we have a really special feature of Russia of excess in mortality within those ages, within working age population, especially among males. So we have also a strong cumulative effect from lagging behind the mortality trend. So somehow this stall in demographic development leads to cumulated losses in death or losses in life. That means that even though most of the deaths occur in the old age, in Russia we have a trend to reduce mortality within working age population, and lack of this reduction will lead cumulatively to the excessive number of deaths. Also, we estimated how this will impact age structure. In the next two slides, I will present few indicators to discuss age structure. To put you on this picture, this is again relative changes, and right now in Russia we have a strong dynamic. Also, this old age dependency ratio, which we calculated based on the threshold of 65 years. So basically, this is the ratio between number of people older than 65 and older to the number of people between 20 and 65 years old. It's multiplied by 1,000, so it's measured in promille. Right now, this ratio projected for this year is 250, and in years 2030 it will be 350. So actually a big dynamic within Russia, and as it always occurs with different demographic projections, somehow stronger mortality, the less optimistic, more pessimistic mortality somehow a little bit improve age structure, as most of the death occurs in the old age. So even there was a really short and small impact within the first few years when this old age ratio a little bit increased, so it's a little bit worsened the age structure due to the lack of number of people within migration, young people migrating in Russia. But later on, it's a little bit improved due to the high mortality. But actually, this is kind of misleading. The major idea of all this different scenario is that actually this is have a negative impact on age structure. Mostly, we see it when we take into the account when we calculate not just fixed age ratio, but calculate so-called perspective age ratio. When we take into account life expectancy, move and estimate the number of people who are living older than certain threshold. For example, when a group of remaining life expectancy with 15 years, to the number of working age population defined as living in those age older than 20, but younger than those age threshold. And we could see that impact of more severe scenario, it's actually dramatically decrease, dramatically worsen the age structure. So I have not that many times left, and so I just basically try to show you the ideas how these different impacts distributed geographically. So what we did, we estimated the relative changes of total population in Russian regions. Relative means to the baseline projections. And this basically encapsulates the idea of how faster than before, than in baseline projection, there will be dynamic within Russia. Actually, in Russia, we have two major trends. A lot of people migrating from the east to the west and from the north to the south. And you could see that somehow, and here we just color-coded for those regions that will be a little bit slower in this dynamic. With the blue color and the green color will be even faster despite of those effects on stolen fertility and mortality, the combination of those effects. So actually nothing changed when we in geospatial distribution, when we see the difference between regions, but you could see within this legend that the scope of these differences differ significantly for more severe scenario. And actually the more severe scenario dramatically changes the speed of this transition. So basically all the east region somehow slow down these demographic changes, but okay, there are different regional patterns here. Also, we try the same approach for working age population. It basically the same idea. We see how relatively changes in population of working age. Working ages, and also apply this approach for old age dependency ratio. Also, you could see for different the smallest and the most severe scenario. Okay, I believe my time is up, so I'm stopping here. Thank you for attention.
Thank you so much, Sergey. You can also close your screen.
Yep.
Now, any questions? Somehow we're not much active in putting questions in Q&A folder. Okay, maybe most of the questions come when we have panel.
Sergey, I do have a question.
Yes.
If I may. And actually, I tried this Q&A and it seems not to work. I don't know if it's on my computer or not. I can't put any question in there. So my question to Sergey, first, thanks for this informative and very interesting paper on outlooks for Russia related to this pandemic. I have basically one question. I was wondering why you assume that in the long term, this mortality crisis that is inflicted by the pandemic will not lead to some sort of recuperation. We know about the harvesting effect, about the selective mortality, and so on. And even even statistical data for crises in the past, like influenza or World War II, or I personally worked on some deported peoples of Soviet Union. In all cases, as far as I recollect, it's like this: you have some spike in mortality, and then it goes back, and you may even have some short period after the crisis when mortality is actually lower than in the trend, but then eventually you come back to that trend. And you, in your projections, you do not assume that. You assume that this legacy of the pandemic will last forever, and therefore you have this lasting negative effect. Could you explain why you assume this?
Yeah, thank you, Dalhat, for a really important question. And actually, we have a scenario, we have only short term, and it returned back to normal trends. But the basic idea, we return to the normal trends with lag. So we just assume that this redistribution takes time, and when we return back to normal, when we again start to improve our healthcare system, start to move resources for those regions like in the life expectancy, it would take times. And actually, what I showed, what I present as a cumulative distribution result, it's a difference between two trends. We have projections when we return exactly the same trends, but basically we return to the same projections to the same trends, but with a few years of lagging. So we lag behind. So that was the idea behind those. So that's why we have accumulated effect here.
Thank you. Thank you.
And plus, Dalhat, there is more and more. So there is, as I mentioned before, there is harvesting effect, but there is also a lot of literature now that there may be long-lasting effect, maybe long-lasting consequences. Even those people who didn't really have hard form of COVID, there may be still some consequences on later stage. So that's we also tried sort of to implement here. Now there is a question from Alexei Raksha. Are baseline demo projections taken from Rosstat on every aspect? Okay, I can answer this since I am also a participant of this presentation. No, this is just our own projections. Of course, we use baseline data we use from Rosstat. I mean, population distributions, some baseline data, but all scenarios, all methodology of making projections, because it's fully multi-regional projections with all adjustments, with iterative proportional adjustments to completely estimate the counts of migrants. So this is all our models. So it's not a Rosstat model. Okay, there is another question.
Oh, okay.
Sergey, could you show diagrams of TFR and E0 projections? Again, Alexei Raksha asked the question.
I just tried to put it online through our demographic representation system, but Sergey, I see that our IIASA demographic site is still missing, I believe, after recovery. Let me just take a few, probably in discussion, I will figure out how to just put it online.
Yes,
Thank
we have
you,
it
Alexei,
online,
for
the
question.
Shown later.
Really interesting question.
Okay, I think we don't have more questions. So with that, we move to the fourth presentation, which is Miguel Sanchez Romero, and he will talk about estimating infection fatality rates and herd immunity levels through demographics. Miguel, the floor is yours.
Okay. Oops. Okay, it seems that I did something. Okay. So preview. Oops. Okay, this is not the, okay, I can use this one, but this is not the actual presentation directly, but it doesn't matter. Okay, so, well, first of all, thank you, Sergey, and thank you, Raya, and also Ranepa and IIASA for inviting me to present this. The results of this paper is called Estimating Infection Fatality Rates and Herd Immunity Levels Through Demographics, and is done with Vanessa Di Lego, Alexia Preskovich, and also Bernardo Quiroz. The main objective of this paper, and what I want to present today, is how we can use the demographic knowledge that we have in order to monitor the evolution of the COVID-19 epidemic. And what I want to present is exactly how we can estimate indirectly the fraction of infected people currently at time t, and also the fraction of detected people at time t. Now, we are going to develop the typical, so we have implemented the typical epidemiological model, the same model. We have implemented it with age structure, and also we are going to take into account the natural mortality rate, so before the COVID, and also the COVID mortality rate using the case fatality rates, but trying to estimate afterwards infection fatality rates. Now, one of the things that we are facing, as we all know, is that there is a lot of uncertainty in the data, not only in terms of the infected people, but also in terms of the how many people are being reported to die because of COVID. So one of the things that we were thinking, and this is what is one of the novelties with respect to most of the Bayesian estimates that we are seeing around, is that we are not using the standard Bayesian approach, we are using the Bayesian melding approach, that is that presented the first time by Poole and Raftery in 2000, and right now is the standard Bayesian methodology for forecasting HIV epidemic. So we are using exactly the same Bayesian methodology, but applied to COVID in this case. Now, why is this important? Is because we are not going to focus exactly on one specific set of parameters, and the confidence, I mean, the distribution of these parameters. What we are going to try to understand is how likely are different models and to replicate the exact evolution of the epidemic. So here, for those who are interested in knowing what is the in-sample performance of the Bayesian melding that we have applied, here we have the death toll in the province of Hubei. The black dots corresponds to the death toll reported by the Chinese government, and the blue lines correspond to the models that we have fitted to the data, and the data that we are using to calibrate is exactly the part that is in this shaded gray area. Now, what we are observing here are actually 3,000 different models that we have fitted to the data, and this is what is speaking for why is it so hard to find out what is the proper characteristics of the epidemic. So here, another way of seeing this is showing the correlation matrix of our SAIR model. So these are the 3,000 different points estimates. And what we are observing here is that what is happening is that they are, most of the parameters that are usually introduced in the SAIR model, they are super highly correlated. So all these parameters are the ones that are giving us all these very similar results. So in principle, what this is telling us is that it's very hard to pin down one specific set of parameters, and it's probably much better to calculate many different models with many different parameters and trying to give a likelihood to each one of the different models. And this is what we have done with the Bayesian melding. Now, this implies that the infection fatality rate after applying the Bayesian melding and running the specific algorithm that is suitable for this kind of data that we have, that is the IIASA algorithm, what we have here at the top is exactly the distribution of the age-specific infection fatality rates that we have obtained with this Bayesian approach. So what we are observing is that actually what the previous speakers were presenting is very close to the mean estimate that we're obtaining here as well. So what this is sort of reinforcing all of us that the calculations that we are doing is, and the results that we are obtaining, they are probably about right. And I will show you the validation of the model in a few seconds, in a few next slides. Now, once that we have obtained these age-specific infection fatality rates, and also the distribution of the different parameters governing the same model, we have applied the model, so 3,000 different models, to most of the countries in the world, to different regions in the world, in order to understand what is the current situation of the epidemic in the different regions and countries. So what I'm going to show you right now here is the application is mainly done, what I'm going to present for the US. This is the estimation that we're obtaining for the infection fatality rates across the US states. What we are seeing in this figure is that, first of all, the yellow colors correspond to the highest infection fatality rates, that they are close to 1.2%, and the purple colors, blue colors, they are for the lowest infection fatality rates. So what we are seeing is that those countries that they have the highest mean age of the population, that is the most important demographic factor affecting the infection fatality rate, is that they will have an infection fatality rate about 1.2%, and these all states, so these states with all populations are mainly Florida, Maine, North Dakota, Montana, and West Virginia, and the states who present the lowest infection fatality rates, that they will obtain an infection fatality rate close to 0.8%, are Utah, Alaska, Georgia, Texas, and the District of Columbia. Now, this is one way of using the demographic information that we are having. So what we are using in this particular case is the specific population age distribution of each one of the states, and also the mortality rates before the COVID of each one of the states. And we are applying the same model to each one of the 3,000 same models to each one of the states in order to get these mean estimates. And we are also obtaining the confidence interval, but I'm not showing here right now. Now, how can we use this information in order to track the evolution of the epidemic? Now here, what we can use is some of the basic equations that we're commonly using. In particular, what we have is, first of all, the infection fatality rate. If we define the infection fatality rate, is the ratio between the total deaths at each point in time divided by the total infected people at each point in time. Now, we can split the total infected people at each point in time that is given, as we can see here, by the susceptible population, in principle is everyone, times the probability of being infected. So if we know the infection fatality rate, and we have a good estimate of the infection fatality rate, we can reverse the order of this equation, and we can estimate what is the probability of being infected at time t. So we can calculate the fraction of people infected until time t by dividing the total number of deaths that we're observing by the population times the infection fatality rate that we have estimated through these 3,000 different cell models. Now, of course, if we want to be sure that what we are doing is correct, we need to validate this model. So what we have done to validate the model is we have gathered the most recent seroprevalence studies around the world. At the end, we have chosen only the seroprevalence studies of 3 countries, and there are Brazil, Spain, and the US. And we have chosen these 3 countries mainly because these are the only seroprevalence studies so far that they are covering the whole population. Most of the seroprevalence studies, they are just focusing on people about the age of 19 or about the age of 16. So they are missing out one specific age group most of the time. So we have applied to these countries because of this reason. And here in this figure, what we can see in the left panel is the comparison between what is the observed fraction of people infected that is reported by the seroprevalence studies compared to the estimated fraction of infected people that we're obtaining in our model. So what we are seeing here is this count of points, and on the right side, what we are obtaining is exactly the error, the average error that we are obtaining by comparing our estimates to the observed. And what we can show here is that after using data 67 seroprevalence studies, our estimate gives quite accurate results because on average we are obtaining an error close to zero, as we can see here. So this is a way of validating the model. So the infection fatality rates that we have presented for the US, they are probably right. And we can apply this model to most of the countries in the world. There will be some caveats, but we can discuss this in the discussion. Now, in this, so we apply this to calculate the fraction of people ever infected based on the previous formula that I was showing. And we are picking specific states. And we are choosing these 16 states because one of the things that I had to say before, here I'm not using as time subscript because what is one of the necessary conditions in order to calculate what is the expected fraction of people infected is that we need that the wave is almost over. So we need a stable already fatality rate. That in this case is the case fatality rate what is being reported. So we need a stable case fatality rate in order to have accurate estimates. So these 16 states were telling us is that they have a stable fatality rate, case fatality rate, and then what we are inferring from the information that they are reporting on the total number of deaths is that New Jersey, New York, and the District of Columbia, they are those who have a higher fraction of people who have been infected by COVID. Now, what is the take-home message in this case is that these numbers are very far still from the herd immunity level, as we all know from most of the seroprevalence studies. Now, the second application that we can do with this, with combining the demographic information and the same model that we have developed, is that we can calculate what is the fraction of detected people. How many people are detecting each government when they are doing this massive testing. So in this particular case, what we have to use is, again, two very well-known measures by now, that is the infection fatality rate and the case fatality rate. So the case fatality rate, as we can see, differs from the infection fatality rate in that in the denominator, we have the total infected and detected rather than total infected. So what is happening here is that the difference is in the probability of being infected and detected. So what is the probability of being detected? So if we divide the infection fatality rate by the case fatality rate, we will cancel out most of these terms, and the only one that we are going to get is the probability of being detected. So the fraction of detected people is exactly the ratio between our estimated infection fatality rate that we have shown and that we have a robust estimate of the infection fatality rate based on the seroprevalence studies and the case fatality rates that have been reported by each one of the countries. So here, what we are seeing is what is the expected fraction of infected individuals in each one of the previous states that we were reporting. Now is ordered according to the fraction of people detected. And the take-home message in this estimate is that even for the states that we are obtaining that they are having the highest fraction of detected people that are Iowa, Virginia, and Kentucky, and Delaware, this is far from even detecting half of the total individuals. So they are detecting less than 50%. We have done this estimate even for 200 countries around the world, and even for many regions in Spain, in Austria, and in Brazil, and we are always obtaining that the fraction of detected people is always much below 50%. So what this means is that that if the less than 50% of the people are being detected by this massive testing, unless that we have other non-pharmaceutical interventions like social distancing and wearing masks and reducing the number of groups that people can meet, probably we will see for sure a second wave. And then it's necessary to keep these non-pharmaceutical interventions in place. Now, if we check what are the main characteristics here between the different states, so the first 5 states and the last 5 states, that are Massachusetts, New York, Connecticut, New Jersey, and Michigan, we have also some interesting result that is shown here, that the take-home message of this figure is that those states that they have a higher population living in rural areas, these are the states that they are detecting with a higher probability the number of COVID cases. And this, at the end of the day, what is implying is that whenever that we are observing an outbreak in a rural area, this is probably going to be quite easy for governments to control. But in the case that the same outbreak is happening in an urban area, this is going to be very hard to control, and probably more lockdown measures will be need to implement it. So to conclude the presentation, we are thinking that the best strategy for replicating the current epidemic through the same models is not just using the standard Bayesian approach, but using the Bayesian melding approach proposed by Raftery and Paul. That the infection fatality rate that we are observing in the US varies by the mean age of the population and runs between 0.7% and 1.2%. Also, that the fraction of people ever infected across the US states is less than 50% of the total population. So we are very far from the herd immunity level. And also that, that the regions who are detecting more the infected people, that they are detecting more is even less than 50% of all the total infected people. And then we should expect more outbreaks, so more waves. So thank you for your attention, and waiting for the comments.
Thank you, Miguel. Thank you. Can you please bring us back to the screen?
Let's see.
And please, when you have your presentation, just check with the chat when I'm sending when you're out of time. So
okay,
please. No, you see. Okay, it's fine. We are still okay. So you have basically 2 questions, both from Alexei Raksha. He is concerned about the data that you are using. He's suggesting that North Dakota seemingly have a very old population, but this could be an outdated information since census 2010. In this census, population became much younger due to shale oil boom. So which data do you use, from 2010 or later? And his second question is, from which source US states population have been taken? For instance, the population of North Jersey shown as 9.5 million instead of 8.9 million. Okay, just questions.
So is the information that we are using in this case is the database organized by Barberi from the University of Berkeley, and this is a super widely used database among demographers, and most specifically whenever that you want to study the case of the US. So this is super updated data that the last release, I think that it came on March. So in principle, we're super confident that the data is quite accurate for the case of the US, especially in mortality data and population data.
Thank you, Miguel. Any more questions?
Sergey, I have one question again. First, Miguel, many thanks for this engaging talk, and I think your estimates of the prevalence are, to my view, are much more reliable than those available from the surveys so far. I have a more technical question. When you showed your estimates for the efficient basic reproduction number, you called it efficient transition rate or something like that, I think. Your range was something below 2, 1.5 to 2, something like that, while the initial estimates were 2.5 to 3 for the basic reproduction number. Is it because of lockdown measures that you take into account implicitly, or is there some other explanation?
So thank you, Dalhat. So there is one good thing is that, first of all, we don't need in this particular case to model the lockdown to do this indirect estimation. This is a very good signal because we can use a very simple model, that this is what we have implemented. And the second thing is the basic reproduction number that we are obtaining is actually around 2.36. So this is the mean basic reproduction number.
Then what was this chart about when you have had this effective transition? Not a transition, but okay, let's discuss later.
I can show you later on the distribution, but
Okay.
the mean in this distribution is 2.36.
Okay, thank you. Thank you.
Anyway, I think we are running out of time. So for our part 1, so what I would suggest, because we are now 5 minutes behind the schedule, I would suggest that we have now a coffee break until 3 o'clock. So it's European time. Yes. So it's until 3 o'clock European time. So we have 20 minutes, which is 4 o'clock Moscow time. So Central European time, it's 3 o'clock. We meet back. So thank you speakers very much for this wonderful first part, and I think it was okay, not much mess.
Thank you, Sergey.
So we are not switching off. You don't need to log out because it will be all on.
I'm here to welcome you to the second part of our demographic symposium. And I hope you enjoyed the coffee. I still do. And in a few minutes, we'll start. We have 3 presenters now, and I see all of them are online. The first one is Dalhat from the North Caucasian Humanitarian Technological Academy, and also an active member of IIASA World Population Program. So I believe in a few minutes we could start.
And I want to apologize that we cannot serve you coffee. So of course, virtual coffee is different from virtual presentation, but still, well.
No cookies too.
That's true.
Sergey, should I immediately share my screen and prepare the presentation?
Yes, I believe that could be the right decision. And we will start just in a few minutes. Try to use F5 button.
I know, yeah.
Yeah, okay.
I was trying to arrange all the windows on my screen.
We all struggle with that. As in previous session, we have 15 minutes for main presenter and a few minutes, about 5 minutes, for questions and answers. And after that, we will have a long discussion moderated by Raya. That's the second part of our event begins.
So thank you, Sergey. First of all, thanks to Sergey Sherbov. We have two Sergeys here. For RANEPA and for IIASA for organizing this very interesting event in such a short time. And it's nice to see that despite physically being isolated from each other, we are mentally so much crowded around very similar topics and addressing this very important issue. So today I'll be talking about how to account demographically statistics of COVID epidemics and indeed of any other epidemics. And first, let me talk a bit about the motivation for doing that. Actually, there are many questions, many research questions and practical issues that need to be counted demographically rather than only epidemiologically. Well, one aspect is quite clear, and it was addressed several times today. It's addressing the demographic cost of the epidemic. So how much lives are lost, how much years of life expectancy might be lost, and so on due to the epidemic. Second, if we want to compare different scenarios and we want to assess pros and cons of different scenarios of lockdown, of fatality rates, vaccination, of weather conditions, and so on, indeed, we need some indicators, objective indicators, that would allow us to compare efficiency of different strategies or outcomes of different conditions. And demographic indicators, they're well suited for this task. Another aspect of why we might need demographic estimates, and actually it was also addressed, this aspect was also addressed today by Miguel. Actually, we could use demographic data that are usually more reliable to check post factum the epidemiological statistics. We know that in many countries there are issues with accuracy, with coverage, and so on, with biasness maybe of COVID statistics. And after the year is completed, after we collect all the demographic statistics, and assuming that demographic data will be as accurate as they usually are in many countries, we may use the demographic statistics to check the epidemiological data that we used to have during the year. And finally, last but not least, if we speak of demographic and epidemiological approaches to studying epidemics, then demography is, in many cases, is dealing with rates as a starting point, while epidemiology is dealing with probabilities or with fatality. And these are two different measures. All demographers know how different they are when we do life tables, for example. And these two different approaches, these two different views to the same process may be very much useful in a combination when we address issues like, is the COVID-related mortality really high? Is the COVID-related mortality higher than the influenza-related one, for example? And here mind that these two epidemics, they have very different epidemiological parameters like timing, for example, and therefore you may not directly compare their fatality probabilities with each other, but you could compare demographic rates, as I'll argue a bit later. Then is the virus selectively fatal for elderly? And we know that the simple answer here is that yes, it is. And indeed, epidemiological data show, and this aspect has been publicized quite widely, that this pandemic is affecting very brutally the elderly populations. But I'll show you a bit later that based on some demographic accounts, we might have a bit on this issue. And finally, but not exhausting the full list of such questions, of course, in order to understand what could happen if the prevalence of infection is higher or lower, we might also need to obtain the demographic rates and to understand how the demographic rates are related to epidemiological parameters of the infection. Demographic account, let me remind briefly that in demography we usually start with what is called occurrence exposure rates, and this is a basic for many demographic analysis. And indeed, this is the approach that I have taken. My idea was to address purely demographically all the aspects of the epidemics and to compute the true exposures in different states, number of occurrences, deaths or infections, and compute the demographically sound occurrence exposure rates, and then, if necessary, to convert those rates into what we need for our analysis, be it a life table or some sorts of probabilities or anything else. And here, of course, we immediately realize that we don't have that same population with a single decrement process and a simple decrement process that we usually have in life tables. We have a very complex population where we have susceptible people, we have infected people, we have those who have recovered. And therefore, the structure of population exposures and of events that I'm counting here in my model, it actually resembles the structure of a well-known epidemiological model, SIR, susceptible, infected, recovered. So I have three groups of people: those who are not infected yet, then those who are infected and could still transmit the infection to others and have not recovered yet. This is group 1. And group 2, these are people who have already recovered from the infection. So for each of these three groups, I actually count the precise number of person years in our population. So E0, E1, E2 are the person years for these three groups of people. Taken together, these three exposures, they give the total population exposure that we deal with in computing the common demographic rates, life tables, etc. I will not go into technical details, but for those who are interested, please request, and I will be glad to share with you the technical details of all these estimates and calculations. The basic idea is to simply, as you can see on the chart, this is a Lexis diagram where you can kind of trace each life of each individual, and for each individual you distinguish these three different stages in their life: before infection, during the infection and disease, and after recovering from the disease. And then for each of these three states, I also count the numbers of deaths. But then when we speak of numbers of deaths, I of course distinguish between, so to say, normal deaths that would have occurred without epidemic and the deaths that are inflicted by the epidemic. So in particular, in the stage 1, when we have a person infected and suffering from the disease, I split the mortality rate M1 into a combination of two rates: M10, which is a death rate that is not inflicted directly by the epidemic, and which is a net effect of the epidemic. Again, without going into technical details, let me go directly to the end result of my formal derivations. So the death rate, and I omit the age variable here, although it's clear that we should compute these rates for age and sex specific, but not necessarily, by the way. So the death rate M equals to the total number of deaths divided by the total population exposure. Each of these two numbers is split into those three subcomponents, and the end result is presented on the screen. In order to provide some intuition to you, let me first look if I have the pointer. do you see the pointer, please?
Yes, we could see that.
Oh, yeah, thank you, thank you. So that this death rate as a result of the epidemic, it may be split into a sum of 3 components. The first one is the usual death rate that would have been in place without the epidemic. Then we have the direct effect of the epidemic. Here we have this, I call it FC, a net fatality, that is fatality of the COVID itself, without the effect of normal usual deaths due to other conditions. So this is the direct effect of the epidemic. And then we have another component that is actually reflecting the harvesting and selection processes. So for example, M10 is a death rate not from the COVID, but during the disease period when the person is infected. So in principle, this death rate might be different from the usual death rate if the epidemics is selective, if infection is selective. If not, then this cancels out. And another summand here is M2, which is a death rate of people who have recovered from the epidemic. Again, if we have no harvesting effects, have no mortality selection, then we may assume simply that this post-recovery death rate is again back to normal M0, and then again this term cancels out. So this term in the middle here, it's responsible for those selection and harvesting effects. So this is a pretty general result. It has lots of parameters, but I will go into details, but these parameters have very clear interpretation both from epidemiological and demographic point of view. And they are relatively easy to feed in. We know most of these parameters, except for fatality. And so we can use this general result to study some specific cases, two of which are presented here. But let me go directly into empirics. And here I have to say that my understanding, it's probably a bit too early to kind of derive the end results for what will be the demographic outcome of the epidemics, because we don't have reliable, trustable, and internationally comparable data yet from many countries. But nonetheless, we do have some data for some countries, and here I have data for China, Italy, and the Czech Republic. And thanks to Krzysztof Zeman and to the BAD and PIC COVID interest group for sharing these estimates of fatality. So here in each of these tables, you see the fatality rates, which is an epidemiological probability that the person infected will die, depending on the age of the person. And then you have age-specific death rate for the same age category for the same country. In this case, I used UN estimates. And what is interesting to point out here is that we have lots of variation in both COVID fatality and age-specific death rates. And that variation is very clear here when I plot the fatality as a function of age for these different countries. So we see that we have this well-known shape of increase by age of fatality, and we have these strong country-to-country differences too. But if we look into fatality as compared to the death rate in the same country, in the same age group, in the same sex, for Czech Republic, where I have data for men and women, and it's interesting to see that actually the ratio of the fatality to the death rate is, I would say, flat. This would be the most reliable result that we may take from these data, because we see that data are very much shaky. We have lots of errors and biases probably, and lots of statistical variation. So okay, I'm coming to an end here. But what is interesting to see here, we don't see a systematic increase with age. So we cannot actually say that the COVID epidemic is kind of is selectively punishing elderly as compared to others. What we may say here is that mortality from COVID is more or less proportional to the usual mortality we have in any age group or in any country. And that leads us to a very interesting way of how to how to assess very roughly the consequences of this pandemic. As you all know, there is a indicator in mortality studies in demography that is called Keyfit's entropy age. And that Keyfit's entropy age shows what could happen to the life expectancy at birth at any other age if you have a proportional increase or decrease in the death rate and across all ages. And this is a pattern that we have more or less in our data that comes up from our derivations. And again, without going into details, it's interesting to see that very roughly we may say that if we have a incidence level for any country, we may immediately, using the formal demography and the result that I have just presented, we may roughly estimate the losses in life expectancy using the Keyfit's entropy. And these estimates are presented in the two tables in the lower part of the on your screen. And these are two scenarios. First scenario is that fatality is double the death rate, and the second scenario is fatality is triple the normal death rate. And so we see the range of possible outcomes of this epidemic, and it's nice to see that this range is comparable and consistent with other estimates that we have heard today. So the last slide by which I'm rounding up is that the end outcome of this epidemic, it seems, will depend very much on prevalence that we will have by the end of the epidemic. And here I would like to point to a very important aspect of the epidemic that I also worked a bit recently, and I have a preprint on medRxiv. You may consult that paper there. So the basic idea is that the long-term cost, long-term prevalence of this pandemic will actually very much depend on population heterogeneity. Usual epidemiological models, they assume homogeneous population, and for homogeneous populations, the epidemic may end up with about 95% of people infected. But if we assume a heterogeneous population where we have few people, so-called super spreaders that are very active, socially engaged, and less alert maybe to the epidemic, and therefore who are catching and spreading the virus easily, and then we have a majority of population who are much more alerted and less socially engaged, and there are some empirical studies pointing to this possibility, then actually this long-term prevalence, this long-term cost of the epidemic might be much, much lower, as you may see on these graphs. So the end result from my assessments is that in a heterogeneous case, when population is heterogeneous, the cost of this epidemic, annual cost, might be about 1 to 3, maybe a bit more years of life expectancy, while in a homogeneous case, which is usually and probably erroneously assumed in epidemiological literature, this might be dozens of years. And these are numbers that are compatible both with historical figures for influenza, for example, and with other estimates we have seen today. Thank you.
Thank you, Dalhat, for interesting estimations. Let's see if we have a question. I could see a raise hand, Paolo Di Giulio. Let me just try to enable it. Paula, could you just unmute yourself?
Yes.
Welcome.
So it's already my presentation. Thank you very much. And do you see my presentation now?
Paula,
so just a question.
Just a few moments. We will try a few questions.
Okay.
Okay, I see there are no raised hands. Probably it was just a mistake. Any questions?
Paula,
Please use.
You can speak, Paula.
No, I don't have a question. I don't know why you.
Sorry, Paula, not Alla, Paula.
Do you hear me?
Yeah, Paula.
Yes, sure.
Okay. I could at least.
Sorry, it was a mistake.
Okay, I could see another raised hand. Di Gelo, if you're with us.
Yes, sorry, so many people with similar names. No, my question is, we can also do it in the discussion, but it was just interesting the way that you used the interpretation of entropy. And we know that this is revealing of the degree of concavity or the age heterogeneity, but there's also the numerator, the E-dagger, which would connect to the inequality in the number of life years lost or the contribution of those life years lost. And I was just curious if you also looked at that function and not only at the age, at the entropy, because then this would also say something about the threshold age, right? At which age would be contributing more or less, or at which ages we are averting deaths or saving lives. So if you could just briefly mention this.
So thank you. That's very interesting and important point indeed. First, technically, I didn't look into other indicators of inequality in terms of lifespan, but simply because the formal result that is relating the relative change in life expectancy to the relative change in the death rate, this result applies only to the entropy age. But you raise a very interesting and very important point that shows that one of the implications of my results is that it's not only the age pattern as such of mortality, it's not only the life expectancy level that matters for how much years and how much people who may lose to this epidemic. And this was widely discussed already, that say Europe and China or developing countries having different levels of life expectancy, they may experience different levels of the losses as well. But a very interesting point that you raise here is that it's also the inequality level that we have in a certain population in terms of life expectancy, inequality in terms of life expectancy. This is also a very important direct factor that affects the human cost of this epidemic. Thank you.
Thank you, colleagues. We're moving to our second speaker. I'm here to welcome Alla Makarentseva from RANEPA. Alla, the floor is yours.
Yes, thank you very much. I'm sorry that I didn't understand previously. So I'll try to make my presentation visible. Do you see this or not?
Not yet.
Not yet. Yes, now?
It's coming.
Yes. I think it's okay now, yeah?
Perfect.
So I'm very pleased to participate here and move a topic to fertility for a while. The COVID-19 pandemic has a comprehensive impact on fertility intentions and later on the reproductive behavior. This impact is associated with both the immediate effect of the pandemic and its medium-term consequences. Firstly, I'll present the estimates of the current childbearing attitudes of the Russian population collected during our survey in RANEPA. And then I'll give some of our thoughts on the short-term perspective of the fertility in Russia. Yes, so Births and Family Society is a large-scale representative population survey in Russia. It has 4 waves already, and it addresses many key issues of socioeconomic and demographic development. It has CAT technology, which is computer-associated telephone interview, and it makes it possible to implement a completely random sample of respondents from all regions of Russia. So, this year, it was conducted from March to May 2020, and at this time, social and economic tensions were growing in Russia. At the end of March, a lockdown was introduced. The survey reached 9,500 respondents. Almost 5,000 of them are of reproductive ages. The questionnaire contains several indicators of the desires for parenthood, and I'll skip all the theoretical framework for this topic because this is not the focus of the meeting. I should say to determine the desired number of children, we use 2 questions instead of 1 as a more traditional. Firstly, we ask, would you like to have more children? And then, how many children would you like to have if you had all the necessary conditions for this? Previously, researchers often didn't ask about the very desire to have children, but only about their number. But now it became important to measure attitudes to childlessness. And so this survey we measure desired number of children, childbearing intentions within 3 years, reasons for not intending to have the child in 3 years, and delayed childbearing intentions. Firstly, we decided to analyze the dependence of these variables on the calendar days. We assumed that from days from March to May, we assumed that different weeks of the survey would reflect a different epidemiological situation and all the circumstances around it. And we wanted to estimate this impact. Calendar days were aggregated in weeks starting from third survey day, and we use logic models with control for gender, age, and number of children. But we revealed that childbearing mood of the population, both men and women, did not change over time during this period. That means that this is not dependent on the spread of COVID-19 and its circumstances, or that at the end of March, childbearing mood has already changed. So secondly, we compared the results of 2020 wave with the previous wave, 2017. Surveys are fully comparable by samples and so on in all of the methodology. Currently, we have only descriptive findings, but they are rather interesting. This figure reports the proportion of respondents not intending to have child in the future. We see growth of preference for childlessness from 10% to 23%. It is difficult to assume that in just 3 years it has grown more than twice. Rather, we suggest that this reflects all the atmosphere of the spring, a set of negative factors, uncertainty, epidemiological and economic risks, and so on. Among young men and women without children, that's aged up to 35, the proportion declaring preferences for childlessness increased from 8% to 20%. Among people 35 years and older, it increased slightly from 15% to 20%. What is more, the share of men and women aged 35 and older, those not intending to have a second child or subsequent child, has increased extremely sharply, from 32% to 52%. And another groups of respondents, there is also an increase in negative answers, but it's slight. Those who declare preference for childlessness are mainly men and women who are not married. In modern Russia, matrimonial and reproductive behavior remains closely interconnected, although the essence of this connection has become quite complex. So some of these respondents may change their minds in future, according to the results of previous studies. That finding a suitable partner is the main motive for revising childbearing desires. But another part of them may completely refuse to create a family. The childbearing intentions for the near future, for 3 years, are better than general desires predict real fertility behavior, although its measuring power is not so great too. For example, in 2017, 56% of all respondents under 45 years answered that they were going to have a child during the next 3 years. This is total answers are definitely yes and rather yes. And this year we conducted another panel survey reaching these respondents after 3 years. And we found that among those who definitely intended to have a child, the share of birth was only 36%. And among those who answered rather yes, only 16%. That's why this wave, fourth wave of survey questions for the intentions has been improved. Previously, a wording was used, I'm going to have one more child within 3 years. And now it was changed to a proper one. It sounds clear in Russia. We replaced the verb with the word planning. So, are you planning to have a child within 3 years? We outline plans as more certain. So I made this methodological digression to say that the findings from 2017 and 2020 surveys cannot be considered literally comparable. But among young childless men and women, the proportion of planning to have a child within 3 years estimated now at 48%. It's much lower than estimates in 2017 when it was more than 65%. The proportion of young women that's aged up to 35 planning the birth of their second child within 3 years is 52–54%. Among women over 35, the proportion of those planning the firstborn is 35%, the birth of second child 10%. So childbearing intentions can still be considered too optimistic compared to real behavior of the population. It seems like the mood now is that people are more likely to abandon plans to have children at all and not postpone them. Maybe it reflects a high degree of uncertainty about the future nowadays, and that this requires additional research later. Finally, I should say briefly about two other indicators. In 2020, respondents were significantly more likely to agree with the point of view that if spouses do not have their own housing and stable work, it is better to postpone the childbearing. Now it is 61% versus 47% in 2017. Next, we have an open-ended question about the reasons for postponing childbearing over a 3-year period. And among the answers were uncertainty in connection with the recent events, unpredictability of the situation that is happening in the world, the situation in the world and in Russia, and similar answers that reflect the uncertainty of the future, including due to epidemiological crisis. So we can conclude that COVID-19 pandemic is impacting on the desire for parenthood, maybe only for a short time, although a considerable amount of people still have childbearing plans for the near future, and it is unknown and to what degree this move will result in real fertility behavior. So currently we do not have a clear picture of far-reaching effects the COVID-19 will have on fertility, but we can suggest that it will be negative in the short time, and current crisis significantly differs from previous epidemics of the 21st century. This lead to the failure of births. 9 months later, the estimate is about 15–25% of the average monthly number. This estimate was given in article by Livingstone. Later, this drop was catching up, and such a pause in pregnancies in Russia can be expected from December 2020 and during at least the first half of 2021. How deep the pause in pregnancies will be and how long it will last depends on many factors, and we can group them. Firstly, direct effects. Childbearing could be postponed by women couples who faced the disease themselves or in their family. In addition, couples who were expecting a child during the pandemic may reduce their future fertility plans because of high stress. Then a lot of economic consequences affected, firstly, those who lost their jobs during the pandemic or faced with other serious difficulties. One of the risk groups is working women with small children, because kindergartens became unavailable for a long time. Later, the experience of lockdowns during the pandemic can give an indirect positive effect on fertility. We're talking about a possible movement of the labor markets to greater flexibility and accessibility of working from home. And this would expand the opportunities for women to combine parental and professional responsibilities. as well as contribute to reducing gender inequality. Such changes could lead to an increase in the birth rate of second and subsequent children. However, at the moment, these optimistic predictions look premature. Next, social consequences relate to long-term negative changes in the lifestyle of the population. These consequences may be stronger for the middle class and the young, highly educated, childless men and women. Finally, mental health also plays an important role for fertility intentions, and the situation in recent months has provoked an increase in depressive and anxious mood. And in addition, one of the most important forces nowadays is the expectation of the second wave of a pandemic and parenting next month. And these expectations will have a significant negative impact on fertility plans for the near future. There are still a lot of unknowns on how COVID-19 affects pregnancy, fetal development, and newborn babies. So couples who have already decided to have a baby may choose not to attempt pregnancy at this time, and it could be months more of waiting. Since it is very important to analyze the effect of pandemic on demography, and we should observe the consequences of COVID-19 not only on deaths but also on births. And all in all, we expect a slight or even moderate negative impact of COVID pandemic on fertility in Russia in the short run. Taking into account the negative dynamics in the number of births in Russia in recent years, we have doubts about a full catch-up after these pause in pregnancies. But pronatal policy, which was implemented earlier, may compensate this partly. That's all. Thank you.
Thank you, Alla, for your fresh data. And actually, we have a few questions. The first one from Alexey Raksha. Could you please share some percentages from the year 2015 and 2013 survey for dynamic evaluation? For example, of childless intentions and something like that.
For childless intentions, I remember that it was about 5% in average on the sample in 2015. But in 2013, they didn't have this question with the, yes.
10% looks, even 10% looks quite low for 5% is just extremely low, but the 23% as you reported, I believe it's just way too much high.
We have estimates earlier in 2007 and 2011. It was also about just 5%. We have a range of service, so it differs recent years.
Okay, we have, I believe, time for another questions. For another question from Schmidt Caroline. Do you have any data on how divorce rate have affected the COVID-19?
Not yet, because our survey doesn't have this information, but later we have this data from Rosstat maybe.
Okay, thank you, Alla. And then we have another question. I believe we will leave it for longer discussion because it's an open question about your ideas. So let's keep these questions for the general discussion. Okay, thank you. I'm glad to present our next speaker. It's Thomas Sabotka from Vienna. Demographic from the Vienna Institute of Demography, Austrian Academy of Science. Thomas, the floor is yours.
Thank you very much. So I try to find out whether the share screen version will work. Can you see the screen?
Yes, perfect.
Super, great. So thank you very much. Good afternoon, everyone. I'm happy to give you a short presentation on the paper we have been working on with several colleagues, Zuzana Brzezowska, Rea Mutarak, Krzysztof Zeman, and Vanessa Pilego. So it's a broader work. We have a long-term, more ambitious intention to study more systematically gender disparities in coronavirus progression and not only infections, also looking at fatalities and deaths. But this is the first paper we have completed, and I'm happy to give you some insights from that one. I think for this audience, I don't need to emphasize the importance of studying age and sex as two basic key dimensions, which are so important for understanding the progression of the coronavirus pandemic, but also its fatality and its mortality rates. I think there are two key dimensions I would like to mention. One is really kind of accounting dimension, that the age and sex composition of the population matters a great deal. And there have been already many studies which tried to emphasize different vulnerability of different countries to, for instance, COVID-19 mortality based on the age distribution of their population. The sex dimension is not discussed so much. But on the top of that, of course, what matters a great deal is also the age and sex pattern of infection rates, because it's not necessarily the case that the infection will spread in the same way across the population, across the age groups, and by sex. We have seen quite a number of studies coming up already on the age and sex pattern in COVID-19 mortality rates, sometimes based on the official coronavirus statistics of deaths by age and sex. Sometimes this is based on the concept of excess mortality rates, looking how many more deaths have been reported for different months and periods of the coronavirus pandemic by age and sex. But still, the research on age and sex pattern is relatively limited, especially for the infection rates. The very, very crude picture based on the statistics, which is being continuously updated by Global Health 50/50, suggests that there is a roughly equal pattern in infections, because women have roughly account roughly for half of the infections if you average the statistics for some 70 countries globally for which this very basic number, just the numbers of infections, are reported on this website. However, the big challenge is that the true underlying infection rates in the population, as we all know, are unknown. The ideal thing would be to have seroprevalence studies for different countries reported also by sex and age, but these data are not routinely published for many places. Sometimes the samples are very small or incomparable, and the age and sex dimension of this is not really reported very frequently. So what we tried to do, and we started some 1.5, 2 months ago already, we started looking at the statistics of the reported coronavirus infections. I will also call them confirmed cases, which kind of is in line with the official way of calling these reported infections. And of course, these could be also strongly affected by the frequency of testing and selectivity of the tested population by things like age, sex, occupation, racial and ethnic status. We know that more recently there has been more of targeted testing in specific population groups, also in regions which have been more affected, or even smaller neighborhoods which have been more affected by the infections in some occupation groups. And the important thing to note is also the selectivity can change over time as testing patterns and frequency of testing and the testing strategies change over time. So one has to take this caveat into account when looking at our data and results. Just to give you a very kind of big, broad estimate of how much the reported cumulative cases may differ from the result of seroprevalence studies. I have seen very nice and detailed results of seroprevalence study for Spain, where the first round has been conducted in late April and the first half of May. And this testing of 60,000, more than 60,000 people resulted in an estimate of seroprevalence of 5% of the Spanish population having had an experience with having experienced the COVID-19 infection. Whereas at the same period of time, the reported share of population who have cumulatively experienced coronavirus infection and has been tested for that is only corresponding to 0.5% of the Spanish population. So we see a difference 10 times in terms of the real prevalence of coronavirus in the population. A very similar result for Sweden, where in late May, only 0.3% of population have been positively tested with the coronavirus infection. At the same time, Swedish seroprevalence study reported 6% of population having had experienced coronavirus. It's a small, much smaller sample than for Spain, so there is a broad confidence interval, but with some exaggeration, we can kind of compare these two results. In Sweden, it's even more than 10 times difference. It's closer to 20 times difference between reported cases and the real number of infections in the population. So this is a big caveat in our study. Nevertheless, we thought it's important to look at the official statistics on the confirmed cases by age, and our main interest is how this differs for men and women. So we had some basic questions. Are men more likely to get infected than women? Does this gender profile of infections, reported infections, vary by age? And are these patterns similar across countries? And our baseline assumption is that especially when we compare the relative measure of male versus female infection rates in a given age group, so we kind of relate male infection rates to female infection rates and compute a ratio of these two, that some of the problem of cross-country differences because of testing policies and data incomparability will go away as long as we assume that there is no strong difference in selectivity in testing for men and for women. So this is a big assumption behind some of our results, and we can then later on discuss this. When speaking here, I use basically interchangeably terms like infections, reported infections, registered infections, and confirmed cases. So when I use these terms, I mean the same thing, reported infections in the official statistics. We were able to locate data or find data by comparable age groups, 10-year age groups, and sex for 10 European countries and populations as of mid-May. German data are a little bit older, referring to late April. We looked at different national reports and some other published statistics based on official sources for 10 countries and populations: Belgium, Czechia, Denmark, Germany, Italy, Norway, Portugal, Spain, Switzerland, and England. So we cover relatively big countries in Europe. I think we cover about half of Europe's population, and we cover most of European regions in this way as well. We use two main indicators. One is we look at the cumulative infection rates per 1,000 population by age and sex, and then we relate the male and female infection rates and compute, as I mentioned, the relative ratios. Here is a table with very basic overview of the data we have used. I don't want to spend too much time on that. Perhaps one interesting facet of this, for the European countries we studied, the ratio of male versus female cases shows that on average, there are more reported cases for women than men. So that's specific for Europe and for the countries we study. Now an example of several graphs which I will show you later for more countries. So this is a very basic comparison of infection rates by age and sex, where you see for Belgium, the spike in female infections relative to male infections at younger ages until about age 60, and then a crossover, and generally more male infections between the ages of 60 and 70. When one tries to compare this, looking at this male-female ratio in infection rates, we have these red areas. When they go down, they show you that there are many more infected women in the population than men. It's a logarithmic scale. When you see them going up, it shows that there are more male infections than female infections. Now, I tried to tell this story in a relatively short time. I show you countries grouped in 3 different groups. One group shows relatively old profile, at least according to the official statistics, in infection rates, represented by 3 countries, Spain, Italy, and the United Kingdom. In terms of infection rates, you see them shooting up at older ages in each of these countries. The scale differs country by country, so don't look, you need to look at the number at this vertical scale. The scale is the same, however, for the male-female ratios, and you see essentially the same pattern, more women being reported, having recorded infection in this coronavirus at younger ages until the age of 60, and then a crossover between ages 60 and 80. We have some countries with a little bit more irregular profiles and younger profile of infections in general, according to the official statistics. And what you see for women here, with some simplification, you see something like an M-shaped pattern of infections at younger ages in Germany, Czechia, and Switzerland. And then rates go up at older ages, both for women and men, but much faster for men. So again, overall picture is more infected women reported at younger ages, the higher prevalence of infection among men at older ages, but kind of irregular profile. And I will get back to that in the discussion. And then we have 2 countries which show really much stronger infection rates among women, again at younger ages, but more regular. And then a little bit more infections, not really much, among older male in Portugal and Denmark. Now, when one puts together these relative ratios of male versus female infection rates for all 10 countries we looked at, you see a lot of differences, a lot of heterogeneity between countries, but one thing is shared, and it's very consistent across countries. There are more women have been infected according to the official statistics at younger ages. Around age 60, there is a crossover a little bit earlier in Norway, around age 60 everywhere else. And then the male prevalence in infection rates peaks around the age of 70, 75. So that's something we were really surprised to see the same kind of thing in all countries. And if you want to put some number to that, the female dominance peaks at age 20 to 29, when the average male-female ratio across countries is 0.6. So we have only 6 infected males per 10 infected women. At age 70, 79, things are the other way around. There are almost 14 infected men per 10 infected women in the population. And of course, this is all controlling for the age structure of the population. So it's based on rates. And there are no consistent findings past age 80, so at very old ages. Now, of course, the big questions on everyone's mind: are these reported disparities real, or are they an outcome of some selective testing? And if there is some truth in this, how can we interpret these findings? And is it likely to be unique for Europe, or hold also for other regions around the globe? Now, is this plausible? I can only say that we were stricken by the consistent findings across countries, but we don't have enough data from seroprevalence studies to confirm that or to reject our findings. The findings for Spain, where I could access the detailed age-sex distribution, didn't suggest any significant difference in infection rates between women and men. But that's one country, one case, and I didn't have access to data for other countries, so we need to study that more. So there are some caveats and reasons why the infection rates may be reported differently. If our findings have some real relevance, we think that older ages, it may actually be that they may not be real, that there might be more reported infections among males, to some extent because men have higher severity in coronavirus progression and are dying more often. And perhaps the higher severity of their cases means that they are more often getting tested at older ages and more of their infections are being detected than among women. But at younger ages, at working ages, our story is that this is likely to be linked with the pattern of female employment and occupation. We observe in all these countries we studied relatively high rates of women's employment. And we know from different studies and statistics that women are especially strongly engaged in healthcare and social care, accounting for 3/4 up to 85% of professionals in these professions, which were really at the forefront of the coronavirus pandemic, dealing with sick people either in care homes or in hospitals and health establishments. And therefore, we think that some of the disparities in male-female ratios in infection rates are also reflecting country-specific patterns of female employment. And we also think that possibly childcare, if you compare age profile, gender profile by age of employment rates, which is shown here for our 10 countries with pattern line, and the gender profile of infection rates, in some countries with more irregular, like M-shaped profile at younger ages, we see some correlation between employment profiles and infection profiles. And the argument we have is that probably at ages where more women are at least partly withdrawing from the labor market because of childcare obligations being on parental leave, the infection rates also probably go down among these women because they are not exposed so much professionally to catching coronavirus at work, at their occupations. Now, this is a speculation. We cannot really confirm this with more solid data and evidence. Now, is this likely to hold for other countries outside Europe? Our argument is that yes, probably this may be the case in other highly developed countries, but no, this is unlikely to be the case in countries with different gender regimes and cultures, for instance, with much lower rates of female employment and different ways, different gender disparities in risk perception and risk behavior, lifestyle, and health conditions. Now, two final slides. One is really suggesting that things may be different in other regions, because if you look globally at the female share of confirmed cases, it's the highest in Northern Europe and North America, and the lowest in countries which really have low female labor force participation rates and low rates of gender equality, like Southern Asia, Western Asia, Southeastern Asia, Sub-Saharan Africa. And also a very kind of crude correlation between the female share of confirmed cases and gender parity index, one of the indexes we were trying to look at, suggests that there is really a link between women's share of infections and gender inequalities or equalities. You can read more about our study. There is a link. I would be happy to send it to you as well. We have published it in Met archives, like Dalhad did his study. And of course, we need to do more also globally. Thank you very much.
Thank you, Thomas, for such an interesting insight that I could already see a raised hand. Irina Kolobichina, I believe she is from Moscow State University. Irina, the floor is yours. Irina, you could unmute yourself to speak up. Just try to put the mouse over the unmute button, включить звук. We are listening. Still can't hear you, Irina, but probably it's a glitch in the matrix. Okay, let's move on. Probably Irina will figure out during discussion how to just open up this question. Thank you so much for this really interesting point of view. We have left much to think about that. So let's just conclude this part of our.
Sergey, if I may, I have a question.
Yeah. Okay.
If I have time for that.
Yes, we have a few minutes.
First of all, Tomasz, many thanks for this amusing story. Really amusing, really interesting, and engaging. I have a question about related to your interpretation of those differences, sex differences in infection rates. I agree with you with what you have thought about the older ages. I think it's really about increasing frailty of men and so on. Talking about the younger ages, could it be that it's this same well-known paradox that men die more often, but women report more health problems? Could it be that women are more eager to report they have some difficulties or some COVID-related issues and so on? Thank you.
This is definitely the case. This is definitely something we have been considering. One way how to get a little bit closer to that possibility would be to get age and sex-specific data on testing. But unfortunately, countries do not really report this. I have seen perhaps one country reporting such detailed testing data. I think it was Denmark. But whenever we look at the statistics, I think let me make it one big message we demographers should be pushing for. We really need more routinely published data on age and sex patterns in anything related to coronavirus, testing, infection rates, hospitalizations, people on ventilators, death, of course. And only when we get this for many countries and for all these different facets of coronavirus, we will be able to understand more. So if we are able to get hold more of testing data, we would be able to answer a little bit better your question. So far, it's very much a possibility, as much as we probably will see shifting gender balance in infections over time in different countries, because, for instance, in my country, in Czechia, now there is a local outbreak in coal mining regions. So if you think that often the future outbreak will be local and affecting specific populations, the gender balance may shift as well, because if it's people in coal mining, it will be primarily men, and then their families, of course, women as well, catching it from them. So this can also shift the gender balance over time.
Thank you.
Thanks.
Thank you, Thomas. We have another really interesting question, couldn't stand to ask it. It's from Schmidt Caroline, and the question about if women in Asia and other developing countries have a low labor force participation rates and that's low infection rate, could it be that could it not be that women are much more employed in informal sector and get tested less?
Yes, this is very much the possibility as well. So until we can see the testing statistics, at least some basics by gender, we will not understand fully these patterns. But at least in some regions, we know already that the infection spread also has to do with migrant workers. In Middle East countries, United Arab Emirates, but also in Singapore, for instance, there have been a lot of infection outbreaks among male construction workers and migrant workers living in dormitories, sharing rooms and so on. And this has been mostly a male pattern. So there are a lot of country-specific ways how the infection obviously spreads. And sometimes it may be affecting men much more than women. Sometimes it may be an artifact due to different rates of testing. So again, much more to be studied in the future.
Yes, a lot of interesting questions to answer. Okay, let's just move on to the next part of our online symposium. Raya, the floor is yours as the moderator of our discussion.
Thank you, Sergey. I think I'm sure we can try to pick up again the questions and answer that we haven't finished since the afternoon or the morning. So in fact, I'm not supposed to present anything, but I would still like to share my screen just because I have discussed with Sergei Sherbov, so we thought we have some kind of the issues that we would like. First of all, we would invite the panelists to pick some of the point that you might like to discuss with us, and then we would like to later on open the floor to the audience. Obviously. So I'm gonna for this part of the program later on, the participants would be able to speak up as well, which I think it's great idea. So you can write what you would like to talk about, but as well as you can also raise your hand and we would unmute your mic for you. So I just want to warn my panelists first that I would call each of you to pick up some of the points here for the discussion, whatever you would like to discuss with us. But I would call upon the last speaker first, so Thomas first, and then go on. So, right. So I guess we have learned a lot. Actually, some of the points that I would like to discuss with you have already been we have some of the answers already. But I guess I just want to emphasize again, there's no need to say that demography or demographers can contribute a lot in this research. So up until today, what do we have? We know the pandemic is still ongoing until when? That's a question we don't know. Next year, another year or so. So things are developed really fast. I guess many of us who've been involved in this research, I myself, we started since March, also because of the outbreak in Italy. So I got involved in the work of Simone too. So from March until this point, we have learned a lot, and many of the models or the data that we have used since March is already too outdated. So we update it regularly. Also, I guess many questions remain. For instance, in the beginning, obviously, we tend to look at what happened in China. But by now, I think relying our assumption on China case is probably irrelevant, for instance. So it's quite challenging. In fact, I think I have to say, for me, myself, for the first time, perhaps, that the research is really, you have to update yourself all the time. Things change so fast, but also probably in a good way, because we know a bit more. There's still many uncertainties. But we have more data, and in fact, Sergei Sherbov himself, since March, he said, wait, Raya, more data would come, and we probably could do more, such as projection, for instance. Okay, so we know that different countries have different continents are under different stages of the pandemic. So first thing is, I think this applies a bit more in the beginning. How much can we learn from the experience of other countries? So we can learn some, of course, because if some country already made the estimated or adjusted in terms of cases, in terms of infection rate or instance. So, but we have to make assumption if we assume that the experience of one country is the same, right? So how much can we apply the experience of one country to another? And at this point, I'm sure that demographers can use some of our models to adjust for that, such as different in age structure. I think heterogeneity is something that pop up a lot and crosses different characteristics, and spatial heterogeneity is also very important. And so now, how much can we learn from another country, but also how much can we learn from our own experience? Imagine in a very sad scenario that probably there would be some subsequent wave of infection. How much can we learn from the first one in our own maybe areas that we analyze? Then some of the question comes from Sergei. We have seen already that there are some evidence of demographic consequences of the pandemic. We've seen excess mortalities, effects on life expectancy, fertility intention, also at least short-term migration. We have seen that. So one of the questions would be, would the lifestyle, so Thomas has already shown actually lifestyle also including labor force adaptation patterns, for example, or even selectivity in terms of risk behavior, or do I test, do I don't test, do I protect myself? So how much of this lifestyle, the variation in lifestyle, influence the susceptibility to infection, and of course also the development of disease, or even how much you're going to seek the treatment, and at the end fertility, right, fatalities, and also the impact on mental health issues. And if we have changed our behavior, would our behavior change? For example, I guess it applies to you all. I wash my hands so often that my hands gets really, really dry. But maybe with washing hands so often in some countries which has issue with sanitation, or people who don't really wash hands that often, actually, I can say in the UK, we have the data before the COVID, regardless of the COVID, only 36% of men wash hands because they put the camera in the public toilet after going to the toilet. So I'm sure now washing hands will change, so that might reduce the diseases, for example. So with these changes in behavior, many things affect also demographic behavior, and if so, how long would it last? Is it temporarily one in the next 10 years or so on? And should we, I think this question also go to the colleagues in our at the Wittgenstein Center too, because we will do the next round of population projection in 2023. So how much, so to what extent that we have to, or should we account for the impact of COVID-19 in our projections? And if we have to, how can we do that? Of course, by 2023 or so, we probably have more data. We might rely less on assumption at this point, but just a question too. And I guess almost a final question, also for the audience that are some policy makers. How relevant is our work in informing policy? Because obviously we also base a lot of our work on scenarios and assumptions. So how much can we help to develop the policy that can reduce the impact of pandemics? Not how certain are you, but I'm sure that we have some message, but how much is that? And finally, would it affect our research, future research in population studies, if anything? So you don't have to go through all of these points, obviously, but maybe just pick up some that you think might be relevant. So at this point, Thomas, maybe I started calling from you first, if you want to share your thoughts on some of the points, or other points as well.
Thank you, Raya. It's a lot of issues, a lot of questions. So let me consider which ones I would like to comment on. I think one, maybe on lifestyle, it's a very interesting question. I think it's the one which is difficult for us to study. How do you find the effect of lifestyle on infection rates or mortality rates across countries in different populations? I've been hearing about this from Vanessa, who comes from Brazil and who is often suggesting that Latin American men have this macho culture, high risk taking, being less careful, maybe also washing their hands less often, I don't know, I cannot say. So this would suggest that in some countries, really lifestyle, and in some regions, lifestyle will really matter in how infection spreads in different groups of population. But I think so far, if I would be a little bit provocative, the way how infections has spread has to do with some eclectic mix of policies, something which happened early in the infection rate stage and how quickly countries reacted to that, but also with the way how different services are organized. So we have examples in Europe of countries where infection rates clearly spread a lot throughout the homes for the elderly, throughout care homes. And these were also the countries which I showed in the first slides of having very high rates of infections at older ages, like the UK, and Spain. And I've seen some staggering statistics in The Economist or somewhere suggesting that 5% of the elderly in care homes have died in the UK due to coronavirus this year. 5%, 1 out of 20. In Spain, it was similar, it was 5 or 6%. Whereas there were countries where the share of elderly dying in care homes because of coronavirus was close to 0, 0.1, 0.2, 0.23%. So the way how the infection has been spreading and shaping up has to do a lot of these things which unfortunately we cannot really predict properly as well. Like we now have all these localized occupation-specific outbreaks or group-specific outbreaks, like slaughterhouses in Germany, coal mines in Czechia and Poland. And I'm sorry to say that, but that's very, very difficult to predict for us demographers. So if there is no big second wave, or if the second wave will be localized rather than affecting the whole country, our projections will be kind of will have a high uncertainty to say something. And one skeptical point about lifestyle, will people change? This is an anecdote. I went to the bar with my friends from Prague, some of them seeing them for the first time in 3.5 months. The first things all of them did, shaking hands. The second thing all of them did, drinking stuff, touching food, and not really caring whether they were disinfecting their hands or not. No protection, life back to normal, and everyone was so happy that things were the same as they were in February. So I'm very, very skeptical about the human nature and about people radically changing their lifestyles for long periods of time. But let's see about that.
Thank you so much, Thomas. I just pick on your last point because it's quite there's a similarity in what we found in climate change research, actually, that people are quite myopic. So if you recently experienced certain events, then that would have some effect on your perception of climate change, for example. But if you experienced flood 5 years ago, you probably forgot about it already. But yeah, I share with you the difficulty in predicting and uncertainties. Thank you. And Ala, maybe I would like to call, and by the way, thanks so much for sharing your results with us. I think it's one of the very, very unique things. I'm sure Thomas would probably like to discuss with you later, Ala, about your work on fertility intention. Would you like to share with us some of your thoughts on the point for discussion, Ala? Thank you. Unmute your mic, please.
I'd like to answer the question I have from my presentation, yes, about what do you think about Lemonstone thoughts about fertility reaction on pandemic-like events. It is about his estimates that fertility rates will fully recover, and that coronavirus may even boost births later after a year maybe. And to my mind, this is rather optimistic estimates because of he includes in his analysis only mortality rates and so on, and he doesn't include differences in behavior and mood of population. So to Russian perspective, I think the recovery will not be fully. So these estimates are rather optimistic to my mind.
Thank you so much. And I would like to ask Dao to give us some reaction.
Yes, yeah. Thank you, Raya. I will start with your last question about our future research in population studies. Well, to my view, it will definitely change. One thing, we will go much deeper into epidemiological modeling and analysis. Of course, we did that already by, for example, studying influenza waves, how they affect people and mortality, by constructing multiple decrement life tables and so on. So we did have some touching points with epidemiology already. But after COVID, I think we'll have much more elaborate models. And actually, it was a surprise to me that we don't have a classical demographic account of epidemiological outbreak, of epidemic outbreaks so far. Probably that's because we always addressed epidemiological issues from very high levels, from after passage of some decades. So we used to, for example, life tables, multiple decrement life tables, we may analyze epidemiological stuff, but in that case, we only study some annual figures, and whatever happens within a year, it's not our responsibility, it's not our interest. But in this case, it's a very fast evolving situation, it's a very fast evolving pandemic and having very large impact. So we have much finer, now we should have much finer, and we will have much finer demographic epidemiological models that focus on within the year developments. This is one thing. Another thing that will affect both the course of the pandemic itself and our research, I think it's whether or not there will be large-scale recurrent infections. So if the same person after some short period of time may get the same infection again, there will be a game change both for the pandemic, but also for the research for our models, because so far, of course, in our models, as in my models as well, we do not care about transition from recovered to susceptible. We have this zero and advanced compartmental models where we only consider this usual role: susceptible, infected, recovered, and therefore immune to the virus. So if this is not the case, if future proves that many people may actually get reinfected again, that will be a change both for the pandemic and for our research. Then speaking of our kind of ways of further research, if you want, or speaking of what can demographers contribute to the research on this epidemic and similar things, well, at least from my own results, it follows that instead of focusing on, for example, age or sex differentials in, for example, fatality as such, we should probably focus on age and sex differentials in how fatality relates to the mortality rate, because it looks like mortality rate, the death rate, the general mortality rate, is the most important single factor of what determines the age pattern of fatality of this epidemic. So if this is the case, then this should also be taken into account in our models, because we know the death rates very well. And last point that I would like to raise here is related to this heterogeneity. I mentioned that only briefly in my talk, but it seems to me, and it's actually a bit a different piece of research that I've done, but I think this is a very important issue. Well, the idea here is the following one. If we assume a heterogeneous model where we have these few super spreaders, that is people who are very active, socially engaged, not washing hands, meeting friends, and so on and so on, then this small fraction of the population will be both highly susceptible to the virus, but also highly contributing to the spread of the virus. But because of their first quality of being highly susceptible, this group has a chance of quickly getting infected and quickly recovering, and therefore moving to this recovered and therefore not non-infectious group of the population. And when that happens, then the basic reproduction number will suddenly drop down, because we will have only less socially engaged, more hygienically careful, more alerted people, and those people will not be spreading infection much around, and therefore this infection may actually come to an end. There is a possibility, to my view, much earlier than we used to assume. Thank you.
Thank you, Dao. I think actually you raised many important points, and actually I just pick on your first point that in fact I'm not sure that there might be even more interdisciplinary or require more interdisciplinary collaboration, I guess, and it might affect, in fact, the way we would, what should we teach then in demography, what other models, and I think that's an important point too. Thank you. And Miguel, please, I would like to call you to share your thoughts with us.
So I was thinking about 2 points. The first one was related to the different behavior and after COVID. And one of the things that I was recalling from historical demography and reading papers from Libby Bacci and David Rare is that most of the time, always after a crisis, there is a rebound, for instance, in terms of fertility. The results that has been presented by IIASA is pointing in a different direction, and most of the studies are pointing in a different direction. But at the same time, one is observing that there are many people behaving in a riskier way than even before without the COVID. So once that the first wave is over, so I start having the feeling that people that they were like in a cage, and after being released from the cage, they need to express all their feelings that they had before, and they are behaving in a more riskier way. So at the moment, for sure, fertility has to fall, but afterwards, after all these feelings will go out, maybe we can expect a higher fertility. But I mean, I'm not the expert. So Thomas and Nala and Raya, you are more experts than I am, but it will be super important to have like consecutive waves along the year of these kind of surveys, just to see what is the trend and whether there is a huge relaxation in how they are responding to these kind of questions. Now, related to how we can use our models and estimates and the demography in order to inform policymakers, something that we have been doing with the model, but before going to the policymakers as such, we want first to have the papers published, just to have the confidence that everything passed the look of our peers. But one of the things that we were doing is one thing that Dalhat was pointing out at the very beginning, that is cross-checking data with our model estimates. And this is super important. This is something that we can do. And through these estimates of the fraction of people detected, one of the things that we were doing is checking what is the different behavior. The state is super wide. The behavior is completely different. But something that we have done at a more local level in smaller countries was comparing what is the fraction of people detected among the different regions, so across the different regions, assuming that given that the population is small, the behavior of the government in terms of testing is exactly the same. And we were able to detect that there are some regions, so most of the regions, they were behaving, they were detecting equally the same, but there were some regions that they were detecting like half the people that they were detecting in the other regions. And then the conclusion, and this was a conclusion that we reached like a month and a half ago, now it's not surprising. The only conclusion that was, so the only explanation that was able to explain this situation was that they were people that they were in a bad labor situation and they were not probably reporting that they were sick. So this is right now something that is very well known, that most of the cases are happening, most of the outbreaks are happening in places where works are temporary. But this is something that we were detecting already like a month and a half ago, just with the model. So these are the kind of things that we can do with the model in order to inform policymakers. And this is a way of going and a way of, at the same time, promoting the power that demography has to give policy recommendations.
Thank you so much, Miguel. I guess maybe because we're not the the frontline discipline in a sense, no? So maybe not many of us yet get approached directly from policymakers, not unlike like virologists or even epidemiologists, but I think you're right. Like, so later on, maybe because we're dealing a lot also with consequences, or we need some more data to be able to do our work. So in a sense, I guess in the later part of the year, for instance, people might start knowing more of our contribution and might, now we don't have to go to policymakers, but they might also come to us. And I think so. And then we also, yes, of course, how we trying hard to communicate our findings and try to show that it's relevant. So yes, Miguel, so we're waiting for your paper to be published. Then I would like to invite Sergey, please share your thought with us.
Which one? We have at least two. Oh, thank you. Actually, we're really interested about different scenario that will help us to improve our population projections. The most troubling questions for me, what would happen with migration? Actually, I saw some arguments about not just the stopping the migration, but increasing migration due to the impact of this pandemic. Something like argument, probably the same logic of this argument just apply to the fertility trends. Somehow, with rebound, with opening all the borders, people are willing to change their condition, their work. But at the same time, we could probably see another long-term structural trend that people are even more willing to work remotely. That will decrease, that will reduce the intention for migration. So actually a lot of questions question to answer using the new data. So I'm looking forward to see how to address these migration questions. That's basically what on my mind right now when I'm thinking about how to improve population projections. Thank you.
Thank you so much, Sergey. I think, yeah, in fact, we haven't yet addressed migration because that's, and then I guess you're talking both internal migration and also international.
Yeah, sure. Specifically for Russia, we have a strong trend, two strong trends from east to west and from north to south. Probably north to south trend will be even more increased, but on the contrary, east to west probably will be reduced, but it's just speculations right now.
Yeah, yeah. Recently, I got asked also about the migration, and I guess the heterogeneity might come in again. You might also think that since many of us have been working from home and many other occupations too, it can also be that migration of certain skills might not happen, but the skills, the type of work that still require manual work, some contact might still happen. I don't know, just my guess.
Yes, let's see what the data will show us.
Yeah. And Sergey Sherbov also would like to say something. Yes.
Yes, thank you, Raya. Well, you know, some of these questions, I also contributed to some of these questions, so I probably answer, you know, try to give some opinion on some of those issues. Well, I think also, I completely agree with Dalhat. I think heterogeneity is a crucial issue here. And following, for example, what Tomasz said, that, you know, when he was in this bar with people relatively young and probably belonging to relatively secure or less risky group of people, so they were shaking hands. Now, my experience here in Austria with people of my generation, you know, we start saying hello to each other, you know, Asian style, you know, not shaking hands. So I think the behavior, again, it's heterogeneity. People will behave very different. There will be different groups behaving different. And that's why it's really important to bring in this issue of heterogeneity. The same will be probably relevant to this hygiene, changing hygiene. Because okay, it might very well happen that there will be less infections because people, again, some groups of people will wash hands, will keep some social distance, may even wear masks in the public places, which very well possible. It used to be like in Asia, where it was very typical. You walk in Japan or you walk in Korea, and many people before the pandemics were wearing masks. Maybe this was partly this cultural sort of acceptance of this, that there was, infection rate was less because people were, having this habit. So maybe also some groups, again, heterogeneity, will be doing that here in Europe or in different parts of the world. Of course, survey, I think, would be a very important issue because probably next year, maybe, in a year and a half, in many surveys, there will be a question related to whether you had COVID or not. So we could really study, okay, unfortunately, probably we won't be able to, to question those who passed away, but at least we will know, we could have some analysis of what was those people who were more or less susceptible to being infected from the service, because we see many other characteristics of people, behavioral characteristics of people. Maybe, I mean, there is now a lot of discussion whether smoking helps or not. So a lot of studies now show that if you're a heavy smoker, then the risk of getting COVID is less. Well, it can be also, some selection of testing, whatever. But I'm just trying to say that maybe a lot of things will become more clear once we have information also people got COVID or not, and we know all their behavioral characteristics. Of course, use of mass media will be very important because that would often, puts things in people's mind. So that's why it will be extremely important that our work, or demographers, epidemiologists, should go through media, because otherwise our meetings, they basically do nothing. I mean, just we talk between each other, and it's important that this knowledge goes to public. One thing about projections, it just, we were doing probabilistic projections, say, at IIASA, we were involved in those probabilistic projections. And we always had, in probabilistic projections, you have some sort of disturbances. Okay, life expectancy grows, but somewhere it can jump up. And we always had, correlation in mortality, very, very strong for these random disturbances. So like if it happens in one place, most likely it will happen everywhere in the world. So that's a very good support what happens now to our approach to probabilistic projections. Correlation is very important thing, especially probabilistic projections, of course. And that's, yes, maybe that should be also analyzed more. I think that's it.
Thank you, Sergey. I'm going to do the Asian style of thank you. Okay, I would like to pass on to Guillaume, please.
Yes, thank you, Raya. Will be short, just to do a small comments on the topics on to what extent we should account for the impact of COVID-19 in population projection and how. I think personally that for the direct impact of COVID-19 on mortality, for instance, we don't need to take it into account on demographic projection, because it's very unlikely that it will change the long-term trends. So this kind of crisis usually have a very small impact on the long-term projections, especially since this one affect mainly the older population. So that means that within 10 years, the impact on mortality will be probably very marginal. However, I think we could need to revise assumptions on other demographic components, such as international migrations. On the short terms, the migration patterns now are completely changed, and many countries will probably experience for the first time negative natural growth this year or next years. And on the medium terms, it can also take a while before things get back to normal. So we know we now have everywhere very high unemployment rates, for instance, and it may take a while before they drop to the past levels. So that means that countries such as Canada, which traditionally welcome a large number of worker migrants, will probably reduce drastically the immigration rates in the following 5-10 years, depending on how long it will take for the economic crisis to be less. So yes, I think we need to revise assumptions, but for now it's maybe a bit too early to say how we can revise this.
Thank you so much, Guillaume. I think, yeah, one thing I should have done it, but this is record. So to write down the possible scenarios or assumption that we, because we have already discussed what would be the likely effect, and that would be something we have to take into account. Yeah. Simone, please. You are the last on the panel.
Last. Hello. No, I'm not a demographer though. So I'm as an economist, I would say it's I'm more interested in the part of policy, if you want, in a way. And I think demography has a lot to say about that. But as Thomas was pointing out at the beginning in his presentation as well, in the answer to this presentation, I think there's still a lot to know. I think demographers should work together with epidemiologists probably in understanding really. So for the moment, we are working on data that are really not reliable. The mortality, I've seen a lot of CFR. We don't know how many people are really infected. We don't know how many people really die for COVID. We have to rely on excess mortality. We don't know even the seropositivity because here we have data, but in reality these tests are really questioned. For example, Germany doesn't do them because they say they are not reliable. A lot of false negative and false positives. So there's still a lot of effort to be done in that direction on the data collection, which shouldn't be, if we want to learn from this in terms of policy. Then in terms of the role of epidemiology after, when more information, I think it's huge. It's going to be huge. And I had a clue of this in the paper we published. We didn't even publish it. We just put it on the internet one day, and the day after we were on the news on the main news TV in Italy, which is followed by 20 million people more or less. And that never happened to me really, to have a reaction that fast. So people were really interested in the demographic aspects of impact of the COVID-19. We were talking about mortality, but the questions were about age, were about sex, were about behaviors, were a lot about this. So this is also an opportunity for demographers, as Sergey was pointing out, to work to popularize demography, if you want, in a way, because it's really something that interests people and the media a lot. And I think it's bad to say this, but it's an opportunity in a way. And for policy-wise, okay, beyond the points of this epidemiology models that can inform the policy in different ways, for which there are also other, I would say, big groups around the world that are doing this type of things. I think one of the issues that I noticed that could be demanded could be that there is a demand for this in for economists and demographers is about the risk and the impact of this thing. Because if you want to set up some policies, so for example, should we run into a second lockdown or not? This is a big. How would we have to do it in the? This depends a lot on the impact that not doing it, the counterfactor basically, not doing it would do. Okay, and the first wave is a good source of information for this. So we can now say if you don't close, if you're not ultra careful about this. You're going to have another X% mortality and another loss of. So this is actually driving the policies a lot, at least here in Italy. Is a scare factor is called, but it's pretty important at the moment. And then for the future, of course, I mean, Dakar, Sergey, and everyone they are top level demographers, so they know much better than me how the research in that area will change following COVID-19. But this was a point of view of a kind of an outsider in a way.
Thank you, Simone. Yeah, I think also maybe in terms of policy, of course, maybe in the next round, we saw that in the UK that they imposing the local lockdown, but maybe lockdown is not the only way now, right? Because we have also containment and tracing and so on. I would like, there's a couple questions in the Q&A, but I also would like in writing, but I also would like to ask if some of the participants would like to speak up, because we have been speaking too much actually. If you raise your hand, there's a raise hand function, I believe, Sergey. And then we could unmute.
Yes, it should work. Yes.
Your mic,
and
yeah.
Stephanie can give word, and I think now people can talk.
Yeah.
There are also some questions, I think.
Yes.
There are questions in the Q&A.
Yeah. So if there's no one speaking yet, I could pick some of the questions in the Q&A. This I'm not sure. I would pass back to the panel or someone else who might want to answer. How can demography handle the cluster hypothesis, the one that's suggested by Tatiana Mikhailova of infection process? So that's one question. And then another question is about how do we make the difference between the death caused by the virus and the death with virus inside? Oh, I think that's the with virus inside. I mean the postmortem. So death with death from COVID and death with COVID. How do we make a difference from that? And then, yeah, so that's a comment that we will be able to understand the whole situation of a medical checkup of severely ill patient and then estimate demographic impact. Yeah, I think it's, we will understand more the more as time goes by, that's for sure. Would you like to respond to some of the questions, like the cluster hypothesis, that's with COVID, that's from COVID?
May I, on this last question, well, I think first that actually the situation is even more complex because it's not a dichotomy, deaths of this type, deaths of that type, because COVID affects also other conditions, other deaths, so it's a very complicated situation we have. But the answer to this question is the same as usual. You model, you study empirics, you test your models against statistics, and then derive conclusions based on your modeling and empirical studies. So that's a universal answer here, I think.
I'm not sure about the last question of the COVID with death caused by the virus and the death with the virus. I think that I did some research into the death certificates of that, how they are compiled in this sense, and it's every country has different rules. So, for example, in Italy, is the first cause of a. So, for example, you die of pneumonia, and but if you have the virus is considered the cause of mortality because it's a sequence of events that was boosted by the virus. So. But of course, it's difficult to really make a distinction between the two. So that's why many countries basically went for excess mortality, all-cause excess mortality, because there is a very much heterogeneity in the death certificates in that sense.
So,
Miguel, yes.
In principle, the standard approach was always the using the death certificates, as Simone was pointed out, and in this death certificate you have several causes of death, so you apply a competing risks model. So in this competing risks model, you pile up all causes of death for all individuals, and afterwards you are calculating in a simpler way, in a very simple way, what is the risks of dying for each one of the causes independent from all others. But you will have to collect all this information, so all the death certificates. But they are tons, I mean, this is in classical demographic books. So just go to a classical demographic book, competing risks model, and you will see how to do it. It's a standard in this.
Yeah, I think the issue is you rely on the death certificates, which hopefully people who fill it in have share the common, say, principles of how to fill that in. So we even have another problem before that, right? And I think my problems, in fact, when we started doing all of this work, it's sort of, how come I don't understand why at the EU level, at least, of the EU countries, why there's not the common binding ways of filling in deaths from COVID, because it varies by country. I understand that the WHO try to kind of give you some guidance, but it's obviously it's not binding. But at the EU level, the European CDC, for example, and I don't think that's a discussion on the table at the moment. Each country just do the way you want. That means you can even hide information if you like. But that's my opinion.
So, I mean, if I may correct you slightly, so at the very beginning, the problem is that the COVID death was not probably in these statistics. So doctors were not able to directly say this person was dying because of COVID. So one of the things is that let's hope that there is no second wave, but the very first deaths in the first wave probably cannot be used for doing these calculations in this way. So only after they started, so until the authorities were able to impose this other item in the death certificates. So from that and then on, it's possible to do this calculation. Before it is pretty much impossible. And of course, we will have to rely probably until a year from now. I mean, we will need to wait until a year from now until we can do this kind of estimations in a proper way. So the problem is timing right now.
Sure, yeah. I think I would like to leave the thank you, Miguel, and maybe the audience would like to, or the co-author would like to say something too, otherwise you only hear from us. Would anyone would like to intervene? Vanessa just posted comments. Let's see if I can in the chat. Right. So how do you think this pandemic will also change how our typical measures to monitor population health are used or helpful? Yeah, that's very highly relevant. And Vanessa, would you like to share a bit your question directly to Guillaume as well? You like?
Sorry. Okay, yeah, thanks. Now, what I've been thinking a lot, and I think it's, of course, I'm biased because I work with mortality, but one thing that has already been troubling me in my research, and then now COVID just put this again into question, is the role of specific measures that we use to monitor health and mortality, like life expectancy. So Guillaume just said that how he feels that the projections will not be affected in an important way because we already have seen how life expectancy reacts to this type of exogenous shocks. But mostly the reason he gave is how this pandemic is affecting the top of our pyramid, right? So it's affecting the older people. And what we have as an experience in previous pandemics is how the younger people are affected, or because we also had other conditions in mortality, so that life expectancy at birth were highly affected. And this gives us the feeling that we felt more, in the sense that life expectancy is more useful to describe the consequences of these pandemics. And this always makes me think how life expectancy is going to become more and more a bit of like, I'm not saying that it's not useful anymore, I'm just saying how we would need also parallel measures to monitor these things. And what I have in mind here is that when you say that life expectancy is not so much affected in some circumstances, this doesn't mean that we don't have like a very dramatic death toll and a dramatic consequence. But because in terms of rates, they sometimes don't affect the life expectancy at birth, this provides the feeling to people that it's not so important. You know what I'm trying to say? So like we have one theoretical concern and implication of using life expectancies, but we have like the pragmatic consequence. So this is what I was trying to say. And I always have this feeling already with influenza. So the yearly fluctuation, I feel like the life expectancy at birth, I'm not saying at age 60 or 65, is like more and more like yearly, it's fluctuating more and more because of the contribution of the elderly. So older people are becoming more and more important to describe the changes in life expectancy. And so if you think about how the life-saving process happens, so Guillaume, you could have like, it depends also on the age structure, like on the amount of people that are reaching those ages. So for instance, you can save 10 people and you give them 7 years of extra life. And then you have a total gain of 70 years. But then you can also save only one person and have 70 years of gain. The type of process of mortality improvement we have seen up until now is always kind of like the second process, in which you save amount of people, but you give them a lot of years, a lot of remaining life expectancy. And more we're living a process in which you save relatively still fewer people, and but you give them fewer years, right, relatively. Anyway, I'm not sure if I'm being clear, but what I'm just trying to say, so I'm like really talking out of my mind because you are all the specialists in this field, so that's the time of being trying to speculate more, is how do you think that, you know, these typical measures that we use to monitor this type of processes are becoming, you know, like not enough? This is my point. And just one last point in terms of health is that we have seen more and more clinical research showing that even though the younger people are not so affected in terms of mortality, they're being affected in terms of health. Like it seems there's a long-lasting impact of COVID on health, on overall health. And maybe you could just discuss a little on how you see that this could in fact impact mortality or other health measures in the mid and the long term. Yeah. Thank you.
Thank you, Vanessa. So again, one thing before I can see in the eyes, everyone would like to react. We slightly over time. May I suggest we run for another 10 minutes?
I think so.
And then we try to close.
Sure,
yeah.
Sure, absolutely.
Thank you. Then please, whoever would like to react to Vanessa's comment.
May I?
Yes.
Well, first of all, Vanessa, I think it's a wonderful question. First of all, of course, I mean, in this particular case, I think we should be more focused on life expectancy at age 60 or even at age 65, because that's where it's more relevant. And it has, well, in fact, what's happening now in the world, at least in most of the developed world, where life expectancy is pretty high, then in the recent, say, 20 years, most of the increases in life expectancy is going just because of the drop on mortality in the high ages. Like if you have this decomposition, you can easily see that. But again, since most of the deaths happen in high ages, we should look at life expectancy at high ages. Another thing what we can use that Simone, Warren, and myself developed some time ago, that was a human life indicator, because I think it will be also very sensitive to this inequality in deaths. So that could be another option to use as an indicator.
We are trying, Sergey, to do that for Italy, in fact.
Any other reaction?
Well, maybe I can say something about, since I am concerned by these questions. Yeah, you're right. Actually, the life expectancy is only one indicator among many others, but to have a real assessment of the impact of COVID-19 on health or mortality in general, we need to use much more than one indicator. And I think in this case, one indicator that could be very relevant would be the number of person-year lost or something like that. That will take into account actually the age composition of the populations, which life expectancy doesn't take into account. And we can measure how many years have been lost by the virus. But you know, in a study, we cannot we cannot measure everything, especially when we have very preliminary data on mortality or when the pandemic is still ongoing. So you know, as soon as we measure something now, within 1 week, 2 weeks, it will be already outdated because there are new data arriving and so on. But for the comments on the population projection, I'm not sure to understand still what you mean, because for this virus, we know that it affects mainly, it will, in terms of deaths, it will affect mainly the population age 70 and above. And for long-term population projections, in anyway, in 2050, this population will be dead, more likely, almost everyone. And they are not likely to have kids neither. So at the end, for the long-term output of the projections, in terms of mortality, the virus will not change probably that much, except if we have maybe other consequences that we don't know yet. But for what we know, I will be very surprised.
Thomas, do you want to say something?
Let me unmute. Yes. So I have 2 points. One is that actually I think that life expectancy remains very, very useful measure because we have hard data on mortality by age and sex from most countries, and we can look at life expectancy at different ages, like Sergey pointed out. Now, think that at the end of this year, in some countries, we'll have life expectancy rates falling, life expectancy at birth or age 65, whatever you want, falling by 2 or 3 years. This is the biggest fall I can remember since the breakdown of the Soviet Union, when some countries in Eastern Europe were going through tremendous mortality crises. So this is a big thing. This is not just, you know, as a small shift, even based on this conventional measure. And the other thing, which I would like to say, I think we really need to distinguish short-term and long-term effects. And I like Miguel points being a little bit provocative on fertility and migration. I think in the long term, the economic crisis, which is triggered by coronavirus, will really change fertility and migration pattern a lot. So it will not be the direct consequence of coronavirus that people are sick or dying. It will be the secondary consequence of the coronavirus, which will be with us and which will probably also change all the parameters of demographic projections. Because when you have a big crisis, international migration changes, like people didn't stop going to Spain or Italy during the economic crisis around 2010. There were no jobs. If there are no jobs, people stop migrating. And with fertility, people don't like to have kids in uncertain times. People may be happy to go back to bars when they feel it's safe, but they will not have many kids when they don't know whether they will have jobs and income next year.
Thank you, Thomas. I was really hoping that you would say something about fertility because everyone was looking at you. Yeah, I would like to emphasize once again the heterogeneity effect as well when we talk about the consequences, both spatially. So if we focus on heavily affected area, even with the direct one and indirect one, you would probably pick up a lot of effects there, and the subgroup effect. I mean, obviously, we hardly do population projection by subgroup, but we might see that in terms of different races and so on. But that's another different thing. Would there be any more? I think we can accommodate maybe one more comment before we close. If not, really, I would like to actually to say that our conversation could go on, obviously, but I sent to the chat as well. So we at the Wittgenstein Center, we are also organizing a conference on the demographic aspects of COVID-19. So that's on 30th of November and 1st of December. The submission deadline, actually, in fact, you guys really have quite hard and solid results, but it doesn't even have to be when you do the submission that you already have some tables to show. The idea is that you may have the data in the future. We would like to see that as well. So that's the link, it's in the chat. So I would like to see the contribution, participation, also from the audience, and also if you would like to invite your colleagues and friends. So we would like to look also at we would touch upon also the economic consequences side as well. So many things that we would like to cover there. And yes, of course, because of COVID-19 is ongoing, as we all know, we were optimistic that we're going to go physical conference. We still would like to host it in Vienna, but we already explored the option of hybrid as well. We can be only people from low infected country. I have no idea, but just to keep in mind that we would accommodate whatever situation that's going to come up by the end of November. So I would like to thank many people, but first of all, Stephanie, actually, she's behind, she's not showing herself in the video, but Stephanie Andrushow is from IIASA, who's helping us with all the organization, registration. I'm sure you have dealt with a lot with her, but also making sure that me and Sergey know how to use Zoom webinar properly and everything. So thanks, Stephanie, so much. And obviously, Sergey for the initiative, but I think I would leave Sergey for the final word.
Okay, thank you, Raya. Well, I want again to thank all the speakers, all the participants of this event, and really a very special thanks to this invisible person under IIASA. Well, I wish she would make for a second her visible. This is our Stephanie, who was really a driving force behind all this event. Without her, well, can we see you, Stephanie?
No, unfortunately not.
Okay,
but thank you very much.
At least we can hear you. So thank you very much, and we hope that it was useful. We will have the recording of all this event, and my understanding is that it will be also available on YouTube. Is correct, Stephanie?
Yes, I will send the link to the registered participants, and we'll also post it on Twitter and on the website.
Okay. So thank you very much.
The slides? Sorry, now I thought I'm going to stop speaking, but I think some of the participants also have already.
If whoever of the speakers would like to send the slides to me, I will upload them also on the website, on the conference website.
Okay, if there are no more questions, no more comments, thank you all, and probably see you next time at some other event, and one of the events will be in December conference.
Thank you. So Gary, we have to do the Asian way.
Yes, bye-bye, thank you. Kapunka.
Kapunka.
Kap.
Ciao.
Ciao.